Good morning, and uh, we are just about to start our technical session today. So, kindly be seated. A warm welcome to all the esteemed dignitaries and the respected experts and the participants who have joined both online and who are present offline here. So, now we are gathered here for the first session today, which is the technical talks by the experts on this third day of the focus group AINN meeting. So now let's begin with the technical session. I would like to invite the experts to Mr. Avinash Agarwal from Department of Telecom and Mrs. Revati from Department of Telecom WPC division to join me on the dais. So now moving on, the first technical session talk is by Mr. Avinash Agarwal from Department of Telecoms. A brief bio. So he is an officer of the 1992 batch and he has 31 years of experience in telecom, information technology, and broadcasting while serving in various positions. So he was also from 2021 to 2024. He was the DDG at Telecommunication Engineering Center, which is the standard setting organization for telecommunications, where he was in charge of standardization and convergence and broadcasting divisions. He was also involved in framing the policies and test procedures for emerging technologies like the trustworthy artificial intelligence and broadcasting equipment. And he was also earlier at Prasar Bharati, where he looked after transformative initiatives for the Doordarshan and All India Radio. He was also involved in rollout of Bharatnet project for providing optical fiber connectivity to Gram Panchayats. He currently the Vice Chair of ITUR Study Group 5 on terrestrial services and Vice Chair of ITUT Study Group 21 on multimedia content delivery and cable TV. So I now invite Mr. Avinash Agarwal to the dais to deliver his talk. I would request also the speakers to limit themselves to 20 minutes due to the tight schedule. Thank you.
Thank you. Good morning. Can we have the presentation, please? So, if we can make it full screen. So, because I have a limited time, so I was wondering like whether I should talk on one topic or multiple topics. But then I thought that it's better to focus on just one topic, which is fairness assessment in artificial intelligence. Next, please. So, because a limited time is there, I will not go into the details. Just cover like we all are aware of the importance of fairness in AI and what could be the sources of bias. So, just for a recap, the bias could come there through the training data sets or through the algorithms used in the learning process of the AI model, or even during the uses, like if we are using the model and it is learning while being used, then the biases might crop in. And then the biases could be on the demographic attributes, which could be like age, gender, marital status, race, and all those things, which are very commonly discussed. But this could be also in other attributes like temperature, time, and these are very important for the telecom scenario.
Recording in progress.
So these are very important for our scenario, because when we are talking of autonomous decision making or IoT or smart cities, then more than the demographic attributes, these other attributes could be very important. So if the decisions of AI are inadvertently being taken on these parameters, these could impact the decisions. Next, please. So, how to measure the bias or fairness in an AI model or the data set? So, there are lots of matrices available. I've just listed 4 of them. Like there are demographic parities. These are just like measuring the probability of any favorable outcome for the privileged class and the unprivileged class. So, uh, I will not go into the details because the time is limited, but lots of fairness matrices are available. These 4 or 5 are the popular ones, but if we visit the site of IBM Fairness 360, then they list around 80 such fairness matrices. Next, please. So we did some study. Unfortunately, perhaps many of you may not be able to read this thing, but uh, some time back, like the reference is also mentioned at the bottom. So 3 years back, we did some study on the limitations of these fairness matrices. So uh, for each data set, these are the popular common data sets like German credit data set or health insurance cross-sell predict data set and others. So we use these data sets, and first we found that whether the data set itself is having bias or are fair. And then we trained AI models, and then the outcomes were checked whether the outcomes are fair or biased. So we used two fairness matrices for the data set, incoming data set, and three matrices like so like we used two matrices for the training data set and three for the outcomes, and then we plotted them. Like this band is kind of a tolerance band, like 100% accuracy will not be there, but suppose we say we accept for plus minus 5%, so 10% variation is acceptable. So anything outside this band could be considered as a bias. So we use two matrices, like the first one, this one, like DI and SPD for the incoming data set, and three for the outcomes after training the model. And so these are the observations that like a single metric may not be correctly identifying bias in all the metrics. Different metrics might be required for different uh, kinds of data sets. Different metrics might be required for the incoming and the trained data sets and all those things. So uh, if we see like just this example, here one metric shows that there is no bias, but the other metric shows that there is lot of bias. So using a single metric may not be a reliable thing. So we need multiple matrices. Uh, Next, please. Next slide. Or I can do it from here. Sorry. Sorry, I can do it from here also. So this is the same data which is like presented in a tabular format. So our concerns were like if we are using multiple protected attributes, like in UCI adult datasets we had three attributes: race, gender and marital status, and then we are using say two for inputs and three for the trained model. So now we have 15 values. Now how to identify, looking at these 15 values, that the model is fair or biased? So we need a single value which can give us some overall idea, and this is a very simple case. In practical there may be say 5 or 6 protected attributes, and we were using multiple matrices for them. So perhaps we might be having something like 20 or 25 individual values. So what we did was we combined them into two new matrices. One is bias index, another is fairness score. So these two were proposed by us in our paper in this. And bias index gives the fairness value of bias of that particular attribute. And fairness score is the combination of all the bias indices of all the protected attributes and the overall bias in the application. So uh, this is the formula that we have used, that this is the bias index and this is the fairness score. So the idea of discussing this is that like when the focus group is meeting and developing the terminology, perhaps I would request the experts here to include the definitions of the combining metrics also in their terminology, because most of the times we are looking at the individual fairness matrices or the group fairness matrices, but are often ignoring the combined matrices. And this is already like involved giving an overall picture. So I would request that these terms like bias index, fairness score, these are also included in the terminology that you are developing. Uh, so, uh, based on the work that we did, we got a lot of positive feedback that why not convert this into an standard assessment process. And so TEC initiated this work in 2022, and with lot of consultations we could evolve this fairness assessment and rating of artificial intelligence systems. So now it is available, and in fact we have created one IEEE PAR also, and now we have already signed an adoption agreement with IEEE, and the process of its adoption by IEEE is in progress. So this is the process, especially for our friends from outside the country, that we follow a very transparent and exhaustive process of consultation. So we started like this was the paper that we discussed, but then we had one round of consultation, then a webinar, open house, then a group of experts from industry and different ministries was constituted. These experts drafted the first cut of the standard. Then the draft recommendations were put on public website. Again, second round of consultations was there. Then again, the experts revised the draft, and then the experts of TEC through DCC and sub DCC, they finalized the draft, and then finally it was released by secretary because it was considered a very important work. So this standard follows this three-step process. Like the very first step is to have a risk assessment, and we are very happy to say that like we mentioned about the 4 levels of risk in our standard, and subsequently like the similar 4 levels were also articulated in the EU AI Act also. So we are not saying like they copied us, but like we all were thinking on the same lines at the same time. So we also have this graded risk assessment in our standard, and this is what the international community is also following. Because same treatment cannot be given to all the AI models. Something which is critical has to be treated in one manner, and which is less critical can be dealt in a different manner. So the very first is the risk assessment, for which we have provided in our standard self-assessment questionnaire, which the developer and the auditor both should sit together and develop, and then find out what is the risk profiling of this particular application. Next is to determine the thresholds, benchmarks, and for bias testing. So like as I mentioned in my graph, like we had used plus minus 5%, but in some cases we can say that I can have a tolerance of 20% or a tolerance of 25%, but in some critical cases we may say that I cannot accept bias more than 2% or 5%. So all those thresholds and benchmarks have to be determined in the second step. And then the actual testing will start, and it will cover the process, the metric, and the scenario testing and other things also. So I have given a very high-level overview, because I was given just 15 minutes, so time is less. We have also covered 6 dimensions in the standard. Like it is not just the data, but even the entire scenario, like even the life cycle stages, the application, different kinds of modalities, data modalities, the ML model kinds, all those 6 dimensions are covered in the standard. And then this is the next step. Like the standard was developed for supervised learning model and for tabular data, but now as we move forward, new developments are taking place. We have lots of image data. We also have unstructured text, which could be like generated through logs of the telecom network, or it could be through social media and other places. And then we also have generative AI. So for that also we did some work and published a paper where we mentioned about how we can augment this standard to take care of these new emerging challenges, because many times the data that we are using is not just tabular. It could be image, it could be unstructured text, or it could be through generative AI. So these are some of the points that we have mentioned, and we are perhaps working, and I'm sure my friends in TEC are taking up. We are evolving this into a new version of the standard, where all these points we would like to incorporate, so that we are able to take care of image, unstructured text, and LLMs also. So I think all these are some of the references that I have mentioned, and thank you very much. If there are any questions, I am very happy to take these questions.
recently there was a news that chat GPT and this, there was a new hallucination was so is it related to this fairness thing or it's something which is inherent in the AI models?
Sir, it is a mix of all, like hallucination also is a result of some bias in the model, because the model has certain preferences which it provides without cross-checking the fact. So, but it is not just bias, it is like a flaw in the model, or it is a flaw in the prompt itself. Like if you give the prompt properly, that don't hallucinate or don't give hypothetical outputs, then perhaps the outcome will be there. So like in LLMs, the prompt is also very critical, but yes, sir, it is to some extent related to bias.
Actually which is checking the fairness of the data model. So whatever the AI models will be check the fairness, that can also be biased. So how to take care of that? I mean, that you are looking for any particular framework which should define the models how to work.
So we are not using any automated tool to assess the bias. That's why we have this three-step process where we first of all identify the risk profile of that. Like if it is something very casual, like maybe some kind of a chatbot, then perhaps we have a different criteria. If it is something which is used in like autonomous car or in some IoT sensor somewhere, like where autonomous decision making is there, perhaps we have a different criteria. So first is that. So it is very important that the developers and the auditors sit together, talk to each other, understand what is the application, and then move forward. I have removed lots of slides because where I discussed exactly the same point, that fairness itself would be biased. Like if we talk of fairness, it has to be very context dependent. So same application being used in India and same application being used in your country, the definition of fairness could be different. So it has to be very much context dependent.
In the process of the standards development, I think it's very important to look into the ethical, non-ethical practices, number one. Number two, up to what extent it is taking away the conventional job perspectives. And I mean, see, there may be a day where everything goes into automated mode, etc. There may be some context which people do not have many of the other opportunities. So I think whether we have devised any such standardization or any method like that, if not, where will it be for that?
Thank you, sir. So, like, this is a very important, pertinent question. So, TRI came up with one recommendation in 2023 where they talked of these ethical principles. They basically copied from OECD. There's this fairness, accountability, explainability, sustainability, and robustness. So, these five principles they mentioned, which are like the ethical principles. And then we ourselves have done some work on AI incident reporting, like if something happens, some harm happens, or to the public also, or to the network, to the governments also, then there should be reported in a structured manner. And I think one draft standard has been circulated by CNB division on standardizing the standardizing the template or schema of the AI incident reporting. So, sir, these are some of the initial steps being taken. But you rightly mentioned that we have to have some uh, guidelines for ethical use of AI. But this is also a dilemma, like where to draw the line between regulation and self-governance. So that is something there, sir. Thank you very much. Thank you.
Thank you, sir, for an insightful presentation. Now I would like to invite Ms. M. Revati, Joint Wireless Advisor, for her talk. Before that, I give just a short biodata. So, Revati Madam joined the Wireless Planning and Coordination Wing as a Group A officer in '96, and then she has been she has represented frequent she has represented as a frequency expert from Asia Pacific region, the Frequency Working Party of the International Telecommunication Satellite Organization, with its headquarters in USA. And she has also assisted Department of State as a spectrum regulatory expert in dealing with international arbitration cases at the International Court of Justice in Hague. She has also contributed and attended various meetings on spectrum management at the ITU level and also at the APT level. And she has experience in radio frequency interference resolutions and spectrum auctions, and her present portfolio is as head of the satellite section, looking after all the issues related to management of satellite spectrum, notification and coordination for orbital slots at the ITU in coordination with the other countries. So now I invite Revati Madam for her talk. Thank you.
Thank you, Ranjana. So the height is a little difficult for me. So very good morning to all the distinguished participants who are physically present here. Also, very good morning and good afternoon, good evening to all the virtual participants. And my topic is, though I don't know much about AI, but I'm seeing a lot of uses of AI in the spectrum management. So I try to bring into the spectrum management where we really need AI, and some people started using, and I see a lot of use cases there. So the first, if you see the tag word, AI will make radio communication smarter. Radio communication will enable AI functioning and connectivity. It is not my word, it is the ITU word when they talk about radio communication. So AI will make radio communication smarter. So AI will help, sorry. Thank you, so nice, Asi. So I think I am comfortable now. So AI will make radio communication smarter. So if we see the first top, there are all the various applications. They all need spectrum. Most of the applications need spectrum. And usable spectrum, though the spectrum is very wide, usable spectrum is limited because your ecosystem equipments are available. The same spectrum, the same pie of the cake, everyone wants it. So how we can do it? We can do using the AI models. Deep learning models, we have a database, we have experiences. Train the models so that we can efficiently utilize the spectrum. The end result is optimum spectrum utilization management strategy. RF spectrum for, we have a D2D, we have a terrestrial, non-terrestrial network integration, we have a LEO communication, I'll come to that later. Then we have a milliwave spectrum, millimeter wave spectrum. It is predominantly used by the satellite and also used by the 5G, 6G now. How we are going to dynamically sharing and using that spectrum? AI will help. Then terahertz spectrum. Of course, visible light, we are not controlling now. ITR doesn't control visible light. Probably in the future, we'll control that. So these are the things. So then I'm just trying to link with where is that radio communication sector plays a major role. ICT plays a major role in the sustainable development goals. And ICT is what is that? Latest technologies, Industry 4.0, Internet of Things, connected cars, intelligent transport systems. They are all depending on the telecommunication network, services and applications. They in turn depend on the radio communication sector for ubiquitous connectivity. You cannot have wireline connectivity everywhere. You need wireless. So there the radio communication sector is a major component in this entire ecosystem. So what is that radio communication sector? Spectrum as well as satellite orbit resources. When I say satellite orbit resources, that is orbit come with a spectrum. And the satellite orbit resources is managed by the ITU because it is an international subject. It's not national like terrestrial spectrum. So then globally harmonized regulations and harmonized standards. That is very, very important. So once the spectrum is identified, then these things will come into play. So this is the interplay of the entire ecosystem. So artificial intelligence acts as an enabler to enhance emerging radio technologies. Fundamental raw material is the radio frequency spectrum. The second, the key developments in AI for spectrum management. Few of things I think we are already using, but to the limited extent. When I say the dynamic spectrum allocation, they AI will enable the spectrum among the resources users depending on the congestion and the demand. That is already happening in the 5G and it is inbuilt into the 6G. But when I talk about spectrum, this 5G, 6G spectrum is also used by the government users. It is also used by the satellites and satellites for different purposes, communication purposes, navigational purposes, earth exploration purposes. There we'll be using this technology. We have practical cases in India. The same spectrum we are using between our NAVIC system, that is the Indian Regional Positional System, and the 5G. So we have a keep of distances, we have challenges, and we see AI will help in that, so that both can. Then interference mitigation. So you all know that advanced AI algorithms mitigate interference between the users of services sharing the same spectrum. When we go to 6G, there it is the concept is already the same spectrum is shared by the multiple applications. So then people can think, what is great thing about it? We are also now sharing. We are sharing among between one mobile service and another fixed service. That means fixed service means I know that it will be here in Vigyan Bhavan, it will be in Sanchar Bhavan. So I can statically identify the exclusions. But in the 6G, what is coming is this is also mobile, that is also mobile. I'll be not knowing statically. It is dynamically, it is shared, the same spectrum is shared. In that case, this interference mitigation is very, very crucial, especially when there are safety services, when there are public services where you have to maintain quality of service. So that is possible with all your help. You'll be developing AI models which will help us in improving the spectrum management. Then next is cognitive radio network. It is a very old topic, but it is a heart of all this spectrum management. Cognitive radio network, it is dynamically, it will be selecting in the particular area that particular spectrum is being used by them, at what level, those things, and it is sensed and it can be put into alternate use. Switch to the best frequencies. The last one is spectrum sharing optimization. See, now the era has gone. Earlier we used to band segment the spectrum for commercial use and the government use. Generally in the US they call federal, non-federal use. In the India we use it as a strategic use or government use and commercial use. Now there is no that static divide. You need to dynamically using it. Like in some cases what they do, suppose some government entity using the spectrum in some coastal area, whenever some ships comes only they use. So it will be detecting whenever ship is not coming, it will be put into other use. Whenever the ship is coming, they know, they plan it, it will be vacated and given for the government users. That is the way. So now in the current era of convergence between terrestrial and non-terrestrial network, see now every day everyone is talking about direct to device. So now this phone so far we are receiving from only our BTS. When we go out of, let us say, go to Himalayas, Ladakh, we don't have terrestrial network. And I cannot carry satellite phone to have a communication there. Now the thing is, this phone will receive from the satellite also. That we call in the ITU parlance, it is direct to device. That means same IMT spectrum you are putting in the satellite. So how to ensure interference-free operation and how to ensure you should not cause interference to your neighboring countries? Because satellite is an international topic. So AI will help me in that. There are developing the algorithms, how it will detect and how it will cause. So in the current era of convergence between terrestrial and non-terrestrial network, adoption of AI into spectrum management is an immediate necessity. It is the necessity. So some of the examples I just try to show how AI will help. The first one is the AI-enabled propagation models. When we do any spectrum management, propagation model is the fundamental thing. So then only I'll be able to tell this signal can go up to this. Afterwards, I can use the other signal, other user. And this propagation varies with the season, date, time, and terrain. And we have more or less static models. Now, people started working on the AI-based propagation models. That is the fundamental principle to make efficient utilization of the spectrum. One simple example I try to show you. In certain period of time, the distance between two services without interference is quite large. If you go to the other side, the distance has reduced within the day. It varies in the season also. So that if you model based on the AI, we'll be able to utilize the spectrum and we'll be able to put more users in the same area. The other side is a cognitive radio network. That's what exactly I explained. The primary, whenever I say PE is the primary user, another is SE is the secondary user. There will be sensors, there will be sensing, and there are some quality of issues can come, but secondary user can take that risk. So primary user, we will not cause interference. These are the users and will be using, there are some applications, and these applications will grow. So then my pet subject is a satellite, and everyone knows now satellite has become so complex with the LEOs and all. So this AI, already satellite operators started using AI to a limited extent in the satellite maneuvering and handover and anti-collision. But there is a long way to go, and probably will be using in a bigger way in the satellite communication. So AI for satellite communication, if we take, because it's a big topic, I try to focus on the fundamentals of it. The first one is beam hopping. If you take LEO satellites, there will be a lot of beams, within 2 hours they'll be moving. And the hopping also, they will not be putting every static beams, because wherever it is passing through, let us say, Rajasthan desert, it need not radiate there. They do beam hopping, they do beam shaping, they beam switching also. Because satellite energy saving is very, very important. My satellite life depends on the satellite fuel there. So beam hopping, energy managing, then telemetry mining. I have multiples of satellites. Currently, I think Starlink is having around 7,000 satellites. They have filed for 75,000 satellites. I need a health of all the satellites. That telemetry also through artificial intelligence only I can do. Gone are the days we used to do with certain sort of intelligence at Earth for the GSO satellites. For the LEO, it's impossible to manage. So then traffic forecasting, like how many users are linked to each beam and what is the data rate they are going to us. Accordingly, I have to divert my spectrum resources there. I'll be reusing that spectrum. So that forecasting and modeling, then interference managing. When we talk about LEO satellites especially, they share the same spectrum with the GSO satellites. The satellite spectrum is highly shareable. So when they come in line, continuously you have to calculate, you have to switch over the frequencies. Otherwise, you will be causing interference. So this interference managing is very critical, especially in the LEO communications. They get less priority compared to GSO. Then space to air ground integration, because they should have proper link calculation also. When you are using in the KU and KA bands, they are highly spot beams. Exactly, they have to steer so that they will have a high throughput with a proper quality of service. These are all possible with integration of AI into this. So that's what I just try to summarize there. Reshaping global broadband and IoT access, demanding robust system orchestration. Challenges, network complexity. Of course, latency is critical. We want it, that's why we are going for LEO. And resource management. Resource management is especially that spectrum and beam shaping and beam forming. Then AI enables. AI will definitely help in that. This one how it is going to do. I just took only LEO satellites. They have a LEO satellites, they are interconnected satellites. There will be continuous handshake. And they should be continuously talk among themselves. And sometimes they take their own decisions based on the training of the models. Because we don't have time from here ground to control them. So quickly changing environments, minimizing signal loss and maintaining connectivity. And also network optimization using dynamically route traffic and manage systems. Because suppose you are linking to one satellite here, there is a GSO satellite also. You should not cause interference to GSO. There will be 3-4 satellites. So you automatically sense and route it to other, because user should not feel that his data rate is going down. Whereas satellite automatically will be switching and routing it. Then similarly, frequencies based on the real-time demand and interference conditions. Adaptive modulation and coding. Signal parameters to maximize the throughput, and finally reshape the beams for optimal coverage and efficiency. Then slightly I'm just going above. It is only LEO I talked. What is artificial intelligence in the space? Now the buzzword, even the ITU, UN has taken cognizance of this. It's sustainability is not only Earth and the sky, it is the space sustainability, complete. The space debris, space situational awareness. So now the concept has come, like autonomous satellite operations, they devise themselves, and in-orbit servicing. So you go there and the satellites will be serviced then and there, and satellite refilling. The fuel has gone, it is, and you will be going to, that is the moon, and you are going to other deep space missions like Chandrayaan, not Chandrayaan, what is that? Adityan, your Mars, Venus. They go, they refuel within the space itself, and the probe will go further. These are all the use cases where, and space tourism, where it is possible only we can achieve with the help of AI, because earlier we have only limited missions. Now it's completely polluted. Many are there. That is one space situational awareness. I've just taken one snap of it. These are so many satellites surrounding our Earth. And satellite debris, satellite, so many things. Now there is an NORAD, one agency, they map, because it is required. They'll be moving. They can damage our satellites, operational satellites. So how to remove them? And if you map them and you map everything, at least with AI will help you. In advance, you have to maneuver. You have to deorient, you have to shift slightly to protect yourself. That is, even International Space Station, they do that, and AI is going to do a lot in this. Then space debris removal and all. So AI for collision avoidance, space situational awareness, integrating sensor data using AI for real-time mapping of the orbital environment. Then deorbit and end of life. Now, ITS has taken a decision, even UN-WUSA, that any satellite going into the space, you have to commit that after end of the life, whether you are bringing it down to atmosphere, if it is a GSO, putting into the graveyard. Now, AI is part of it, and AI will be deciding at what time it has to go to graveyard or it has to go to, because it should have some fuel, then only it can be maneuvered. Then finally, the regulatory and spectrum compliance. Where is that we want it? See, when we made any filings, satellite filings to ITU, ITU examines that. So this AI-based examination will help at ITU, BR, it is the secretariat for all satellite filings, national administrations, because it files to national administrations, and satellite operators, where it is required. When I file ITU, we have to tell these are this is my constellation, and this constellation is going to affect, these are the satellites which I will be coordinating. These all things can be possible when I am doing for 75,000 satellites. Humanly it is not possible, even existing algorithms it is not possible. The AI only has to come and help us. Similarly, regulatory compliance analysis. Then they say which satellite I am going to affect, or which satellites, which particular satellite system is going to affect our satellites. That analysis, we have visualized and all some software. Still, it is under development, further improvements. So I think that will help there. Another last one is interference resolution. Triangulation, because within it is a terrestrial interference, it is little easy, it is in your territory, you know it. If it is coming from the satellite, you don't know, it's very difficult. We have a triangulation method. And with GSO, it was a little successful. Now with LEO, so many things. AI has to come and play a part. So I see a lot of AI usages. Without AI, probably future spectrum management, we cannot even imagine. With that, I hope I have not taken, I completed in my time. And for any questions, I'm open.
I have one general question. It is related to not satellite. In fact,
Yeah, please.
we are giving so much of power to AI. It is taking decisions itself. Earlier it was command and autonomous type of thing. Now, do we have in future also? Do you have we thought of about having so much of control that AI is not doesn't malfunction, or it is some virus or something is there, and in that case it may play havoc because you are giving power to AI in satellite case or other cases. So it has to be very foolproof system if we have to allow AI to work in so many critical fields. So anything about that is there in mind?
Yeah, it's a good question. I think AI people will be able to throw more light on it. But now, because you have to take the help of AI. By the time you decide here, suppose two satellites are coming very closely. By the time you decide here and send the command, you don't have time. Havoc will happen. It has to be on-board processing and own intelligence there. But your point, probably people will take care while develop that system. The command from like from the ground is really, that is not a solution. Sir.
Want to ask one thing. I think what I understood basically it's more a use case of the AI, and so far you talked about the DSA. These are actually in practice. It is working now. I mean, one of the band, the full band, when you work for the web searching and something like that, it goes into a lower band. If you want to do some gaming, etc., automatically it takes you to a higher band of the frequency. So this type of DSA things are already working. It's in practice.
Yes, sir.
And the important thing, what I want to know here, I mean, it's very fine. AI can be used everywhere, wherever some human intelligence have been there. A sort of replication, you can always do it by AI. Why not only on satellite or orbit or anything, anywhere you can do. My question actually, see, I saw somewhere that orbits now, it's become another scarce resource. And I saw somewhere that possibly, suppose India, now we think of doing something around 50,000 satellites in the form of LEO or MEO. If we want to put it into the space, then possibly there may be a shortage of the orbits, and the ITU may not be in a condition to do that. The advice that was given that India may borrow it from some of the orbits that has already been allotted to Russia and some other countries. That means countries like Russia and others and few more, they have already booked spots or the satellite orbits. What India has done, why we had been waiting, why we could not do that? Yeah, that's the
Sir,
question.
thank you, sir. It's very good. Sir, when you file to ITU, when you send a filing to ITU, there are some regulatory timelines. So, India, we have a GSO orbits. Whereas in GSO orbits, we have filed and we have some orbits and we have our own satellites operating there. When you file to ITU, within 7 years of that filing, you have to bring the satellite there and make it operational. Otherwise, you will be losing the priority. For the GSO, we are in that place, okay. And there is in the case of GSO, there is well established regulations. That means even the countries which they come later, they have some planned band. That one orbit is reserved for each country because people will not go and hold all the spectrum. It is not on first come, first served only, certain portion is reserved. In the case of NGSO, it is not the case. Still regulations are developing, people are filing it. Now in the WRC 27, for the new bands, this concept has brought. The country should not be deprived of. So when come to India's point, even if India, if we can go and file 15,000 satellites, we should be able to bring into use by, there should be use cases by within 7 years.
What I want to say actually, for example, you might have seen a practice what has already happened.
Yes, sir.
IPv6 that we are moving into.
Yes.
It already happened before we could conceive that a huge number of that
Yes, sir.
physical addresses has been taken away by USA, UK, and other developed
Yes, sir.
countries.
Yes, sir.
And actually, had it not been done in time, IPv6, India would have been one of the sufferers.
Yes.
I'm talking of that. Why that foresightedness not was there with us? If Russia can do, some other country can do, they can book their orbits. Do you think Russia has done everything? As you said, even the norms are not coming.
Yes, sir. Yeah,
India
I
also should have done that.
No, no,
We
sir.
also should have applied for 50,000 satellites
Yeah,
and
yeah.
booked the slots.
Yeah.
We have not done that.
Yeah, yeah,
Now they're suggesting borrow it from Russia. Why should we borrow?
No, no, sir. I'll just take it a little. For the LEO systems, Russia has not filed anything. For the LEO system, it is a Starlink by the US and Norway, and OneWeb is by the UK, and China has also filed LEO communication satellites. We have LEO non-communication satellites. They are of only Earth observation, remote sensing and all. But these 75,000 or 60,000 are of communication satellites. And you are correct, we will become only consumer market, India, if you don't fire. And the most suitable location is 450 kilometers to 700 kilometers. If it is highly crowded, the same spectrum coordination will be difficult. Now, India through InSpace is trying to engage with the industry because it's the satellite operator, which has to build the satellite and put. So I think India is seriously thinking to do it. And when we come to LEO, it is a global market basically. That's point, sir.
To that. Now it is thinking.
Yes, sir.
But where the thinking were there 10 years before.
Yeah, exactly,
It should
sir.
have been done when many of the countries they have already reserved. And I was told, you said that Russia is not in LEO. Please check. I was told that enough of the orbits have already been reserved for Russia because they submitted plans. And what happens possibly India or a group, we could have made some groups with UK or some other thing, could have entered into that. Consortiums are possible.
Yeah.
So somewhere this way, that way we could have entered into that we also get scope for reserving some of the orbits.
Exactly.
That I do not find. That
Exactly.
didn't happen in India.
Yes, sir. Actually, as you correctly told, 2014 onwards, that momentum has started, all this Leo explosion. And yeah, I agree with you, sir. India's left behind. I think, thank you.
Thank you, ma'am, for the very enlightening presentation on satellite and use of AI in it. So now I would request Sri Rudranarayan Paley, sir, member designate on the dais, for presentation of mementos to the speakers as a sign, as a token of thanks. First, I would request Shri Avinash Agarwal, sir, to come forward. I now request Revati ma'am to come forward. Now I would request Avinash sir and Revati ma'am and Sri Rudra Narayan Palai sir to everybody congregate on the dais for a group photo. Sir, a group photo, please. So now we move on to the next part of our session, which is the Buildathon. So I'd request Ms. Preksha to take over now. She'll start with a brief overview of the Buildathon, and then we will move on to the teams and their presentations. Over to you, Preksha.
Good morning, good afternoon, everyone. So, I'll give you a brief overview about Buildathon. Buildathon is a collaborative event with FGAINN. It is designed to explore, prototype AI native solutions addressing both next generation telecom network requirements and societal challenges. Buildathon is organized into 4 stages. Stage 1, demo proposal. Stage 2, implementation. Stage 3, initial implementation. And stage 4, final demo. Today we will see the final demos of all the teams. We have received 10 We have received 25 contributions and we have shortlisted 10 teams who will be presenting their demos today. The objective of this Buildathon is to have hands-on learning, prototyping and implementation process experience, collaborate with industrial, academia and industrial institute. The most important outcome for this Buildathon is learning. The evaluation criteria for the participants is: 1. The aim of the demo proposal should be clear, well defined, and in relationship with AI native networks. Is the scope of the contribution clearly explained and based on the overall design be focused on specific scenarios for the demo? Criteria 2. Is there a clear mapping between demo scope, functional and non-functional requirements and demo objectives? Are there practical implementation options and testing options? Evaluation criteria 3. Are the test cases clear and well documented? Evaluation criteria 4. Does the initial implementation show clear progress towards final demo? Evaluation criteria 5. Does the demo show clear mapping of initial design? Are there valuable learnings called out of in the final demo? And each of these 10 points will be scored from 1 to 10. The evaluation will be done out of 50 points. Thank you. Now I will call the teams. The teams, Ranjana, over to you.
So the first team is AIONet, and the participants listed here are Prithvi Krishna, Miss Varsha, and Miss Nilanjana Chakrabarti. So they can come on the dais and then do their presentation.
Good morning, one and all present here. So, I'm Varsha from VIT Chennai, and
I'm Nilanjana from VIT Chennai.
so we are here to present INET. It is a lightweight, explainable, and edge-based system that helps in monitoring the traffic. So, imagine we are in a situation where you are a rural doctor and that you're having some a live consulting with patients, but there is some lag in the video. Because and then you later on find that it is because of something some system update or some downloading stuff which goes on in the background. And then this is something which is not because of poor internet alone. This is because of the user end's traffic. So our INET, it reduces or it monitors and controls the traffic at the user end so that there is some smooth flow of traffic and there is there is no congestion even at the router end. So over to Nilanjana to explain the database.
Our database is the heart of our system. It is where the feedbacks are logged, the user priorities are logged, and which is again used for the AI for learning. So when the next time then the same app comes, the AI knows what to prioritize it initially. So there are 4 main tables in our database. Our first table is app metrics. The app metrics table stores our app name, the CPU usage, the bandwidth, the priority which is calculated, and the timestamp at which it is stored. The second table is app priorities. It stores the app name, it stores our app name, and the initial priority which it was given, and then it stores the overridden priority and the timestamp. A third table is a feedback table. It stores the app name, the initial priority, the overridden priority, and the timestamp. And the fourth table we store is other unknown apps. So, like for example, sometimes it is not known about the app, like there's no specific port to app mapping, so sometimes an unknown packet might enter that network, and that is logged into this table. So it contains a unique app signature is created for these kind of unknown packets, and that app signature is stored, its first seen and last seen, and the timestamp is stored in this fourth table. Now we'll move on to Varsha for explaining the core logic.
So this INET, the core logic is to prioritize the right app traffic at the right time, so that it is actually intent and intent based, that is user based. Later on I'll explain how it is user based. So it is initially app behavioral based. So the first thing what we are doing is we collect packets. We sniff it through SCAPI sniff function, and then each packet at the user's interface, it is grouped into a flow control. So each flow, what is flow is, in a sense, is there is a destination. The PID is actually the source IP address, destination IP, and port. All they all form a unique key. So this is what is flow. This is what flow is. And then we do the mapping, port mapping, where the PID is mapped to the destination port. And based on this, we classify it into known apps and unknown apps. For all those for which we know the PID, it is classified into known. And for all those for what we don't know the destination port, that is classified as an unknown app. So we handle known and unknown apps both separately. This is a plus point of our INET. So, and the next thing which we do is the important thing, that is the prioritization. Based on what does the app traffic is controlled, it can't be simply a simple logic like what comes first can go first. Instead, we are prioritizing based on the application behavior. The application behavior is the CPU percentage. Why we are considering CPU percentage is that CPU at times it depicts intense process, it depicts some complexity in the process which is assumed to be some important process. So we have we can't just simply classify it into based on CPU. So we have other types like the packet count and bandwidth, based on which we prioritize everything or each and every packet. So the thing is here, each and every process of the prioritization is done in real time. So we do not have to worry about what if there is some change in the app priority, what if there is a user wants to change the priority. So here we offer another option. So each and every user, it is user independent. Like what I get in my system may not be hers. So each and every user have their get their chance to edit the priority in our dashboard. So they can edit it and they can use it. They can edit it based on their intent, and that is why we call it as a intent-based model. So this is completely non-radio as expected, because non-radio is very it enhances the security, and there is no fear, and it is rule-based. There is no fear of that if there is a bad outcome or something. So the next thing is bandwidth shaping, obviously. So whatever, based on the priority, we shape the bandwidth dynamically. That makes the system traffic efficient and lets the packets in an efficient and orderly manner, so that there is no traffic accumulation at the end. So over to Nilanjana.
So we have all heard about the known apps. What if we want to know about unknown apps, like unknown packets, or like even custom packets? So we have also included an option for sending custom packets to the network. This will be primarily used for security testing and to show how our AI adapts to even these kind of packets, not just known or unknown packets. So in our custom packets, what we do is we use Python's scapy class, and we extend it, and we add additional subfields to it. So the subfields there are 4 subfields which are added. The first one is a 2-byte integer. The second, the other 3 fields are all fixed data by strings. So this custom packet is sent to the network, and then what our AI IONet does is it does not just discard them. It logs their app signature, and it again enters into the pipeline of classifying it as either known or unknown apps. Same thing goes on for unknown apps. Sometimes what happens is when there is no port to app mapping, the packets become classified as unknown. So what do we do with those unknown packets? Sometimes they can be malicious also. So what do we do is, again, our IONet gets an app signature, and it logs them into the unknown apps database. And what is also done is there is a security app details section in our dashboard which showcases all these unknown apps, so the user can get to know whether these unknown apps are like unknown packets are like, did they enable them, or are these malicious. Now we move on to Varsha again for the monitoring aspect.
So before monitoring, I would like to clarify that policy injection. So we also deal with policy injection. So the user, as I already said, user have the right to change the priority. This overridden priority is indeed, as she explained, is indeed stored in the feedback database, and then it is used for future monitoring of the data packets. So now coming to the monitoring part, we have 4 layers in it. The first layer is the application layer, where we calculate the CPU percentage, the bandwidth, and prioritize it based on that. And the second type is a network layer, where we where we capture the packets, find the total number of packets in each application, and then count the find the data number of data the length of the packet. And then this is also involved in the prioritization part. And then later on comes the unknown packet handling, which already she explained. And the next part is the feedback thing, which we already explained. So now let's move on to Nilanjana for the next.
I will be now be showcasing our dashboard. So this is how our dashboard looks. So there are different stages, like different parts of our dashboard. The first part are the applications. So these applications are the currently running applications in the user system. These are refreshed every 2 seconds thanks to the Flask socket IO command which we use. These are refreshed every 2 seconds, and all the app information and metrics are shown. So the CPU, the bandwidth, the priority which is already calculated is shown. Now, and we also provided the override. So what now the user can do is, maybe like if they have opened Zoom and Zoom is showing a low priority and they want it to be high, so they can go here, they can click on the override button, and they can go to the drop down and they can make it high, and it will automatically become high, and the bandwidth will be allocated likewise. The second part is the security alerts, like how I discussed while I was discussing the unknown packets handling. The security alerts are also refreshed every 2 seconds, and they showcase all the unknown packets which are passing through the network traffic. And again, it's upon the user, and this is like show an alert. So if the user has opened an app, and if it's malicious or not. Next, I'll be talking about how is it related to AI native. So first we should know, what does AI native mean. AI native means it's not applied with AI, it is built into the code. So we can confidently say that IONet is AI native because first and foremost it is cloud independent. And we'll move on to Varsha for the next.
So yeah, Here is a common question that we get that strikes our mind. This is already existing. What is new in it? It is in the first thing is this is in the user end. We try to maximize and prioritize based on user's intent, which is not replicated in the routers. So here is the difference between the traditional routers and our IONET. So the first one is that the traditional routers use static port based rules, but we are using dynamic port based. The second one is that they apply limits or shaping per interface, but we do it for each and every packet. They cannot see the application the routers do not have information about the application context. Here our IONET model, it can classify based on the PID and the destination ports into different applications, like whether it's Zoom or Gmeet or anything. So the next common question we have is, yeah. So now let me just try to explain that how the statistic view. So basically, if there is about 1 in 5 user using this, there would be a 10% reduction in the overall network traffic, and then there might be a 35 to 50% or 60% reduction in the users end during the traffic of network traffic. So this can raise a question: why is why how can it affect the overall network traffic when each and every router and user is connected using different connections? Here comes the part. There is a backhaul of the route in the backhaul of the routers, everything merged. So this reduction in the user end can reduce significantly the traffic at the routers, therefore reducing the overall traffic. The comparison is not between routers and IONET because they both work together. They both have a common part. We can implement the same flow of IONET into the routers and for satellite, as ma'am said, for dynamic port dynamic port mapping, and dynamically reducing the network traffic, which we aim to give at the user end too. Since it is easy to implement, we have implemented in this. I would like everyone to watch the implementation video. Optimizes network traffic in real time with no cloud, no training, and full explainability. INS follows what Gunter says: end-to-end optimization, not chain of blocks. Our AI agent scores and classifies every application in one go using CPU usage, bandwidth, packet behavior, and encryption. The logic is simple, effective, explainable, and fully runs at the edge. We enhance the network by reshaping traffic in real time. AI enables this by assigning dynamic priorities to flows, optimizing what's urgent and delaying what's not. Here we would be able to see that certain things are marked medium and certain are below.
Here's our dashboard. It updates every 2 seconds based on what you can see. Priorities, which instantly updates species and is stored in our knowledge base. The application layer communicates with the network layer, while the AI logic applies scores based on both runtime data and user inputs, enabling a feedback-driven loop. Runtime data and user inputs, enabling a feedback-driven loop. To support emerging applications, AI ONET
I
lets
hope
you
it was
create
clearly.
new packet formats. Here, I'm crafting a custom packet.
I hope it was clearly visible that whenever I opened a new application in my laptop, there was a record in the dashboard. So now coming to the knowledge base part. The knowledge base here we are using is an SQL database which she showed. So this has a feedback table. That is where the learning takes place. AI agent learns through the feedback table and it applies it for the future packets of an unknown application.
Packet with 4 custom fields and an 83-byte payload. Now we are clicking on send packet, so the packet is sent into the network. AI unit handles it seamlessly, scores it, logs it, and even reacts to unknown protocols. So yes, we generate and process new packet types.
What if an app uses random port, say a malware or misconfigured sync service, and it logs it as an unknown signature and infers its priority based on real-time frequency? Light database. Under security alerts, thank you. We would like, if time permits, we would like the judges to watch the videos. And thanks a lot for giving the opportunity. Thank you.
Thank you.
Yeah, thank you so much, Team Airnet. Before we open the floor for questions, I request Vishnuji to please explain the evaluation criteria.
Okay, good morning. Yeah, thank you very much. We are getting several questions on the evaluation criteria, so let me just explain from a mentor perspective what is going on here. The template of the presentations that you see on the screen will be exactly same as you saw just now. Every team will present their basic idea. There will be a recorded recorded video, and they will explain that one by one. One specific question has been asked to them to explain to you, that is how this is AI native. This is the template which you will see for all the presentations. Then you see this paper in front of you who are evaluating. Basically what you will see is the sequence of all the demos that you will see today. One by one are here, one by one. This is the sequence that we will follow today. The current set of comments are here. This we have been doing for the last several weeks, few months actually. This set of comments have been very clearly communicated to them. They know these comments, and this is what we have discussed. The main theme of the demo is the first line that you see in this. Each of the team, the main theme is mentioned. So in case you don't know what you don't clearly get, or the team does not communicate clearly, this is the point A, that is the main theme. That's where you read firstly. Then after that, there are certain questions which we have been debating with the team. Yesterday, day before, we had mentoring sessions offline. Before that, we had mentoring sessions online. So these are the questions which we have been discussing with the team. You don't need to worry too much about it. This is just for your information. Then the comments needed from the committee are 1, 2, 3, 4. They are the same for each team. They are the same for each team. These are, you're requested to ask subjective comments, or you can note down here what are your subjective comments. I won't read out here because that is for our own benefit. But basically, if this is for the guidance of the teams, we hope they benefit from your experience and subjective comments what we are asking. The last one is really important, which is they are there related initiatives which they should be pursuing. This will help us as mentors as well to take this forward. Another thing is, next month we are having similar activity in Geneva. It will help us to take some of these initiatives forward in such extensions of this build-a-thon going forward. For ITU, this is an ongoing activity. So please give subjective guidance. Your experience will be very valuable for the teams. No need to worry about objective part. The guidance and the comments and the questions which you ask will create more value for the teams. For the teams, I'm told that many of them are very tensed. I don't think so that is required. I believe we can have just informal demos. I think what we should do is, however, please show a picture, use the time, use the videos, and start with the videos, go through the picture and explanations clearly. You're hand-picked, you are the best, no need to worry, no tension. I mean, these guys are very friendly people. All of these are very friendly, very experienced, nothing to worry for the teams. Thank you very much.
Thank you. We forgot to ask, are there any questions left for us from the judges and from the audience? Yes, sir.
Thank you. I just wanted to know whether you have thought that if I manually override all the priorities as high, will it cause any robustness issues? Like if there is something which is medium or low and then I just put everything as high? Will it cause any issues?
No, sir. Since this is, based on dynamic bandwidth and dynamic map prioritization, though you can override everything is high, but at the end we follow first come first serve. Like if two priorities are written as high simultaneously, we follow what comes first will go first. So that would avoid conflict and also, can satisfy the user's intent also. Yes, sir. Any other questions? Or
I just have a small doubt only. The way you presented looks like it's more a programmed, not a programmed software or an application. Does not look like an AI agent. What exactly is the AI agent you are talking of? Number one. Number two, will it work on the real time?
Yes,
Well,
sir.
how much time lag it will be incorporating into the system? Additional time lag for the particular application.
Yes, sir. So coming to the first question, whether this is AI agent based, and yes, we say it is AI agent based because it is rule based, and we are calculating the heuristics and we are scoring it based on which it is dynamically allotted. And even we also have a JSON file which has all the port rules and other rules which we have. And then based on those it is dynamically allotted, and then we are also learning from it based on the feedback which user gives, and whatever is stored in the feedback data table, we are learning from it also. And coming to the second question about if does it work real time? Yes, it works real time, sir, because we are using Python's SciPy library which captures data in real time, and we have also kept the refreshing time and everything so small that it matches with the packet flowing. So if you could watch the video, you will be able to just confirm that it is working real time, because the moment I open the Spotify, 1 second, I hope I have time to show this. Yes.
Base is SQLite.
1 second.
The feed schema includes app priority feedback.
1 second, sir. So it's getting logged real time. So when we open the Zoom and then close it, I hope you will be able to see once it comes up. Yes. Yes, sir. Sorry. If we were able to do a live demo here, we'd be able to show it realistically. And then the calculation of CPU and everything, it is done for each packet based on application basis. So I don't think it would take much of a time. Does that clarify your question, or is there any other answer it requires? Yes, sir. Thank you. Any more questions? Yes. Thank you.
Thank you so much.
Thank you so much.
Thank you, Team AIONet, for very nice presentation. Now I call Slice Minds for their presentation.
Good morning, dear judges, ladies and gentlemen, all present here. I am Harsh, my mentor Anirvan sir. We are from SRM IST Chennai, and we are here to present our idea that we have implemented quite a bit. We enhanced it during the two-day session as well. So our main idea is to develop a current marketplace that is not there and enhance it in the new coming 5G and 6G era. So our basic flow is if a customer want a current slice or a network requirement, we want the customer to directly come to our marketplace and can have that specific requirements so it can perform on the specific slice Currently, there is a pipeline of network which does not specify their requirements or understand the purpose of using it. So we define different functions to find the intent of the customer, to understand how the AI will explain why it is using that slice, and through we have considered a flow of our marketplace. So here you can see initially is the client input what he actually wants. So inputs comes from the use case, the JSON files which are in our API documents and goes through the post APIs. These all are the inputs from the JSON with the regions with helping what type of API, what type of slices, what type of different specifications the user wants. How the AI help in this? AI classify the users with 2 or 3 different methods. We started configuring using the 3GPP pipelines. Then we moved to GSMA for increasing the efficiency and the prediction of model more. And currently we have intent-based model also. You can just type what you need and it understand and give you the slices perfectly. These are the client maps that we uses. Currently in the 3GPP we have currently 3 common slices, the EMBB, the URLLC and the MMTC. EMBB used for mostly video watchings using any entertainment purposes. URLLC is used in military, hospitals or very low latency areas. And MMTC is for the IoT services. So current QoS requirements, as you can see, we use the bandwidth, reliability and the location purposes. These are other different device headsets, security levels and priority decks we can give to the clients. Now we can move on to our digital twin feedback.
What do you call client registration? Sorry, vendor registration.
So yes, here will be the full flow of the slice required requirements. The vendor will be deploying in the client onboarding. So vendor will select the slice. As you can see in the document, the slice classifies, the AI classifier will classify the slice. The LLM based on the scoring, we are using dynamic scoring functions here. We are using different neural network function because rule based will not work here because every user have different requirements according to their functionalities. With the composite mathematical functions, we are trying to dynamically allocate the resources to the vendor deploy slices. Then vendor will send back the feedback to the user and the client can deploy the slice in the system. Currently, these are the key suggested network functions that we are using in our model. So first is the SDTF function, which automate the selection and vendor requirements from the slice and through the vendor APIs. Then we have the vendor slice agent, which assign the slices from the vendor to our marketplace. Same we have the entity and SCDC. It pushes the slides through the UEs into the vendor marketplace and the entity compliance give the telemetry of the different slices. Here you can see how the AI agents get the data from the vendor and how it allocates through the different reliability. This is automatic payload function that goes through the slice allocation. Same here, the vendor displays the slices with the different configurations. And here you can see this is the final slice that the user get after the vendor delivery of the deployment slice with the UI.
The configuration
yes.
for
These are all the UE functions and SDC functions.
we have tried to define them for the implementation in 6G scenario so that these can be implemented so that it becomes a AI native function where our functionality can be directly deployable. So if you see that finally in this scenario, so this is the final configuration which the vendor, which the client gets, so that he can configure the UEs and his systems for the particular slice. And from here, deploy slice. So it starts from the vendor side, that the vendor registers itself with its own facilities. We put that also as an input in the in our system, so that the judgment and the capability of the vendor can also be put as a ML machine learning part. When then the client comes into the picture, the client gives its requirement, and in different forms, either it is in a form-based scenario or in an API-based scenario. Even we are taking it as a LLM model, where the client only writes about their use case, and we from the use case we are taking out the requirement or the what kind of slice they will require. We are suggesting that, and then we are putting it to our AIML setup, from where we are deciding that what is the kind of which vendor is suitable for this, because we have already taken the vendor capability input before when the vendor has registered. So depending on that, we give two to three options for the client. The client selects that particular slice, and then we deploy that slice. We have that's why we have created a function only, so that direct deployment from the marketplace to the vendor API call can be there, and vendor directly deploys that slice and gives the configuration back to the marketplace, which is again given to the user side, the client, so that the client can implement the UE functionality. And then the entity is a backside where we are also monitoring the functionalities and the scenario for that particular slice, health of the particular slice, and depending on that we are also increasing, decreasing or manipulating the scoring accordingly, because for the future use cases, and even that we have not yet implemented, but warnings and all also can be initiated from the marketplace if the specification of the SLAs which are been promised is not delivered properly.
Yes, so I will show a quick demo of our marketplace. Here you will be able to see a AI prompt box. The prompt box is to identify the intent of the user. So if a user doesn't want to identify what slice it wants, he doesn't need to know. He can just directly put his use case, and we get the thing from there. So currently we talk about the data, how our model is trained and how it is very efficient. So if you can see, these are the data points we have used. So I think it is visible. All the timestamps, traffic data, load hours, how much traffic is there, optimization slices, current slices, what slices using in which format. This is the data visualization graph for over different slices, different traffic simulations and different activations. And this is our LSTM model which is we are using for configuration and monitoring our slice functions. So you can see there are 200 points which are forecasting and which are getting high and low peaks in the model direction. So we will show the current demo functions, like a user just said, I want to run my autonomous vehicle to our marketplace. We will allocate a URLLC slice for the lowest latency. Our model finds the intent from the sentence and allocate the correct slice to the user. It goes directly to the step 3 because step 1 is step 2 is under the 3GPP guideline to understand what slice the user wants. But from an intent, we can identify that as well. So the AI will process completely. It will give it a score, and it will score all the current vendors that are available in the marketplace. We have shown how the score is calculated as well. Like this, this is a neural network we are using. The neural network will identify the dynamically importance of the system. So we have the weights. The weights understand the concurrency of the data, and the concurrency finalize the score of the current user. Accordingly, we find the best vendor, and it will be deployed in the model. So these will be the deployment configuration for the customer, which he can be deployed in their system correctly. Here the QS metrics and the monitoring parts come in. We are using a LLM based agent and a MCP server. So we are taking the context from the internet as well as from the system of the user, where the user identifies if any problem in the current slices are occurring. So if you can see the Gemini analyze and the context 7 analysis, the URLLC part is correct or not. Optimization results will be also provided to the vendor side, so they can improve their slices as well. So it should be considered as a end-to-end system. We try to solve our black box nature of the AI problem, which the AI doesn't explain why it is not working correctly. So we try to implement that part using our MCP server and LLM agents. Then we have the domain knowledge integration, where we use the domain of the user and the vendors to integrate the knowledge and give the correct results with mathematical and composite AI model functions. And at last, we are kind of proposing 3 functions here. First is the AIMF function, which is the AI intent mapping function, where AI will have the intent to map different type of functionalities from the marketplace or from any kind of systems. The second function is SVSF. So it is the slice vendor score function, where we don't use rule-based function like currently we use in the EC or telecom market. We try to make it dynamic, because every time user doesn't need every slice or every possible vendor they want. we want to make it dynamic. So we initialize that function that can be used in anywhere in the native part as well. The third function is the trust and SLA scoring function, which help us to identify what trust and how the scoring will work in the market scenario. So currently we have these, and for the 6G market scenario, we have some.
Yeah, these are the proposed scenarios for AI native, which we are trying to do. As he has mentioned, few AIMF, we have it converts the service level. So these are all definitions which we have given in the document, which we think we can work around. And then at a management and orchestration level, also we have some suggestions which are there. We have used different parts for that in our use case, and we think that if these are a part of the AI native scenario, then definitely we can have a better working of our model. And definitely marketplaces for 6G is slice marketplaces for 6G will be a very common thing anyway. So I will just show the so the strategic justification we are putting up, that it aligns with the design philosophy. It's an intent-driven, dynamic, SLA assured, policy compliant slice network slicing. So this is our main pitch line which we are putting up, and it is an operator control function to ecosystem marketplace. So ecosystem marketplace functionalities are not available currently in any form, but as we can see that slicing and selling the slices in a particular way will become a big part of 6G. So these functions we have tried to implement, orchestrated in some parts. Some parts we have just imagined it and done some simulation, but this is what so we have tried to write down most of the things that what we think that it should be there. Thank you.
Clarification questions.
I'm here. I have one question. Thank you for the presentation. The question is a little bit of a challenge. Imagine that we want to take your software, your demo, and we want to put it into a production network, in a real network. You didn't explain exactly how would you assume to be training the model. So before the system is actually capable of identifying the proper slice according to the requirement. And
so we are using a historical data setup here,
yes,
which we are training. So we have some synthetic data currently with us, which is because see, each of the defined setups which are there, they all have their own limitations in the system. So depending on that limitation only, and from the context which we are taking out, we are mapping these two things out and creating it.
So it would be based on probably a database or records from the operator who wants to implement
yes,
your...
so sir, if you can see in the screen, can we show the screen?
I cannot do anything, I'm just talking.
Okay. So we are using a LSTM model, that is an auto-regressive LSTM model which has the entity feedback loop. It controls from the user side and on the historical data as well. So we predict if you are using correctly and forecast as well. So then we compare it with the forecast scenario, and then we use mathematical equations to identify if it's correct or not. Basically a decision tree we will make. So, and for the production part, it is a compliant system that we can use for the production as well. From the network layer, it should be connected to the vendor department, and it should go to the client-side server through the JSON format currently.
Anirbanji, I think to answer Ricardo's question, you should probably go back to the Open 5GS and the lab that we discussed.
Yeah. So sir, we have tried that part also.
Simulated
that,
Open
we have
5GS.
simulated a basic scenario where we are using 3 core Open 5GS core setup in container lab, and we are creating different user scenarios where we are getting each slice giving around 3 to 4 pairing up. But we cannot show it in the demo we discussed yesterday because it's all the black screens. Okay, so we have not done that. So that part we are doing. So in that we are trying to create some apps in between, and those apps only we want it as a functionality which should be there, so that it becomes a AI system.
So still we are creating different functionality to get it actually native inside functionality. If not the marketplace, we can use function in different areas.
Because these functions are very common for slicing as a scenario also. It's not only
the marketplace
scenario. These are common functions which we see.
Thank you. Any more questions?
Hi team, very good presentation. I have just one question. Suppose if some URLLC operation is going on, remote surgery is going on, and a slice you have recommended, then suppose the SLA is not met in between, will your software change the slice?
So that is, we are not the owner of the core setup. So we are not the vendor. So what we can do is we can reduce the scoring of the vendor for that time, and we can have the alarm system that we have implemented, but we are not controlling the slicing or slicing activity. We are a monitoring setup, and definitely that vendor will have a very low score in that kind of a specific kind of a slice option for the next time. That we can assure. We cannot, we can have safeguards like this, but we had a thought that we can do something, that we can have one or two, depending on the priority of the setup, that we can have two slides, one as a backup slice which we can init, but we have not yet thought of that.
But suppose if you take up a backup slide sort of thing, will not it take some time for the network configuration?
Definitely. So actually, we have implemented a fallout system as well. So if our marketplace doesn't allow, or if because of some technical issue, the slice did not get allocated, so current slice of vendor will extended the time till the slice will get allocated, and it will fall back to the rule-based system that is currently working. So the network doesn't go anywhere till our slice will not deploy it.
One suggestion: can we limit the number of users on a slice from vendor perspective also, so that a load balancing sort of done?
Sir, we can have this as a monitoring part where we can, because it depends on the vendor, how much vendor will allow us to work it around. But definitely that's a good thought, that the monitoring part, and we can have some control over it. We have not gone into the control angle that much for the.
We are trying to develop the dynamic functions as well to deploy the bandwidth differently. I remember you asked yesterday the same question on the bandwidth. So we are trying to deploy a dynamic function which differentiate the bandwidth between different users. So we will try to do that as well.
Okay, thank you.
But the implementation, we have to see that how the vendor will give us the, because we want to work like first as a marketplace, so that we have all the control on the result and ranking scenario rather than directly on the operations. But definitely some operation functions can be put into, so that we can make more assurance that the whatever criteria is given is maintained.
Yeah, that would be a more approach toward AI native, when it will be self-configurable and self-autonomous sort of system.
Yeah. So, but on that part, I will say that we assume that that part is more taken care by the vendor itself, not by us. Because then we are getting into the vendor's role.
It should be into the core of
we are more into the monitoring part rather than the operations.
Yeah, I think Daneshji's question is important. You should probably take it down and perhaps take it as the next step. I think, like you are saying, monitoring may be the way to handle it from your side.
But definitely we should have some control over it, because we are the face, because people are coming to us, not to the direct vendor.
But monitoring control loops, closed loops, actually, that may be the first step to handle Daneshji's question. And also, I think your self-healing, the real-time self-healing that he is asking, that's an important part.
Yeah, that we can, because we can work between multiple vendors to give a second option. It's like how your Ola Uber breaks down and they give you a second car. So something like that we can definitely, we are already looking into. Thank you.
Thank you so much for the telecommunication department for the opportunity. Thank you for the build-a-thon.
Thank you.
Thank you, Team Slice Minds. Now we will take a break. Let's meet again at 11:30 IST.
Recording stopped.
22 minutes.
Tell them.
सर ने बोले बाहर मत जाओ जाने से बट वी विल बी काम लाइक चिल हो जाएगा इसके बाद
Yes, sir.
No, like we can open it here. Ma'am, we can like directly log in, you're saying? Log in. Yeah, that's all. अच्छा ये आपका all judges are not like now. Oh, that video also no. But your video is there. You only want to show that. I guess that video is there. Which one? This is the one. No? You want the other video also?
No, this one.
Check ना ये जो कमांड आ रहा है वो उसमें भी दो वीडियो सेट मैंने ड्राफ्टेड वाले no see just check में कितना no this is Raju's thing नहीं हाँ हाँ ठीक है sure प्रायोरिटाइजिंग वाला था तेरा
Okay, चलो
2 मिनट सेकंड वाला कमांड क्या था 2 मिनट्स इस पे जाके हाँ 20 मिनट्स चलो मैं सब बंद करता हूँ जो हमें चाहिए वही ओपन करते हैं यू वांट कैनवा आल्सो नो नीड Well, this also has my account, no? It would have got directly signed in.
Yeah.
Good morning, everyone. So this is Team SNR. Myself, Nitya, Raju, and Srirang. We are second year students from RV College of Engineering. So here we propose our proof of concept called NetSpeak, which is basically an AI native assistant for intent-based router configurations. What is the motivation behind NetSpeak? Over to Srirang.
Hello everyone. So basically, let's take a simple case. Whenever in my home there is any problem with the Wi-Fi router, what do I do? I generally dial up to the network administrator, ask him to fix this issue, and this generally takes time. And this is the major problem. Traditional routers are heavily reliant on manual intervention, requiring engineers to possess deep and specialized knowledge of these complex commands. And these complex commands are various because there are many devices different devices, different routers contain multiple different templates. And this generally increases the manual intervention, which leads to errors. Responding to, and in cases of any outrages or traffic congestion, this makes it very worse. Our vision is to move towards an AI native network, which is imagine a network which is autonomously translates a general comment which an user gives, which is expressed in general terms, and then it gets converted into complex commands, complex CLI commands. This is where AI becomes transformative, especially in the non-radio parts of network, for example, network routing, switching, and service delivery. We are focusing on how AI can drive the automation of these crucial network functions, making the network truly intelligent and independent. Let me run through the exactly how our flow works. So basically the user gives an input. So it can be any general input, for example, prioritize my video calls, prioritize this particular application. For example, this meeting is running. We can ask them, prioritize this meeting so that it doesn't lag. It classifies the prompt that we have given, resolves it, maps it to the exact CLI template what we need to use, depending on what device it is based on. Then we fill in the values, maybe the bandwidth, baud rate, or anything. Then we check for the syntax of this particular CLI template which I have generated. Then we compare it with the pre-existing template that is there, whatever router configuration is there. Then we push it to the router. Now let's start with understanding, let me show the demo also. Over to Nitya.
So through our proof of concept, our aim is to generate CLI commands and verify that they are valid and syntactically correct. We're not covering state management as of now. Our aim is to only generate commands, and we have done it for YOS routers because during mentoring sessions we were advised to not wait for a vendor to rely on templates from them. So we went for open source routers. So YOS is a Debian based network operating system which we have used for our demonstration. So let's go through the demonstration once. Okay. So this is how our UI looks. So we have a slot for user to enter, and we have some suggested inputs, and we have a block where generated CLI commands will be displayed for the user. So suppose I enter a very generic input like prioritize my Zoom calls. This goes through the step of intent decomposition. Intent decomposition is one of the major feature where we can tell that our AI native part stands for, like understanding natural input and doing input parsing to obtain a very structured JSON object which can be used in further CLI generation is where our innovation lies. So we have also used Jinja templates for generating for the router configuration commands, and we can see here that the input that we have given has been parsed to obtain the application, the action, and we have provided two more fields to be more specific, suppose duration and zones. So after this, the user, we can see that the commands get generated, and it is just for the user to know what are the commands. To verify that they're actually correct, they're valid, and they're syntactically correct, we'll be pushing them and making sure that they get executed without any error prompted. So for that, we had to set up a virtual YOS router, and you can see that we do show configuration commands and filter it by QoS commands. We can see that here, whatever commands that were displayed to the user has been, how do I zoom out? Pardon for the clarity, it's not very clear here, but we have updated it in our talk. So these are the commands which you can see that are getting reflected once being pushed through the SSH. And regarding the tech stack details and implementation, over to Raj.
So proceeding with the tech stack, we have used Next.js with Tailwind CSS for the front-end part, and for backend we have used Flask server, and we have used Paramiko library to push CLI commands through SSH to YOS virtual router, which you can see up there. And talking about the impact, it simplifies configuration and automates configuration generation and reduces the dependency on the network administrator. Thank you for the Department of Telecom for providing this opportunity, and we are open for any questions.
And also in the mentoring session, we were asked to show, okay, these were few questions that we had during the mentoring sessions, how we can, how CLI is being only changed for that particular part. And then we also have the basic Jinja template that Vishnu sir had mentioned us to include. Yeah, so the basic Jinja template.
This is one of the example that we have. So we'll be plugging in the values to this and then executing these commands to apply that policy.
That's it, sir.
So I think in the next version of the demo, what would you implement? Let's say if you were to go for the next edition of the Build-a-thon, what would you implement next?
Sir, for now, we're just focusing on CLI generation and making sure they're syntactically correct and valid. But to actually predict the values, we can, in fact, inculcate a lot of ideas that has been presented in this Build-a-thon itself, like for state management properties, and especially the first team which presented, like for the prioritizing logic, how applications can be prioritized. For that, so the future scope would be allocating the exact values. So we are just applying and shaping traffic now, and we are applying QoS policies. So to predict the exact parameter values, we can include the ML models.
Yeah, but I think more importantly, I believe these experts should ask what are their views, but I think it is more important from a standards perspective. It makes sense to look at another set of router implementations. Currently,
Yes, sir. We'll be extending it to different vendors and routers.
Yeah. And currently, what you are using, Jinja is for what purpose again?
Sir, it's like we have a set of, like we have a template which will be reused again and again, so that only the plugin values are kept, the variable things.
So that means that it gives you a structure.
Yes, sir.
So that means that if, let us say, if you are, instead of using YOS, you are using Cisco.
We will have a different Jinja.
Yeah, no, but then you will be able to capture the formats in Jinja. Common format in Jinja across VOS and Cisco.
Yes, sir.
That is better demo than what you have now. That is probably a next step for you.
Yes, sir. Yes, sir. We can.
That's what I think, because from a standards perspective, it makes sense for us to every step to be general, and one step behind, because now you are able to handle not only iOS but Cisco also.
Yes,
right?
Yes,
and that scalability is what matters. But I think you guys should.
Yes, sir. Any questions? Sir? Yes.
Thank you for the nice presentation. My question, another little challenge. The problem that you wanted to solve is very clear, and the technology, the methodology is also very clear. And from the demo, it seems it works. Now, the question is, if you had to assess how good your solution was, Or for example, if another team would have implemented the same AI-powered troubleshooting mechanism, which KPIs would you show for, let's say, assessing the quality of your results? Is it the time to solve the problem? Is the amount of problem you can solve? How do you assess the quality of your
Yes, sir.
results?
Yes, sir. That's what. So our existing solution is only till the syntactical validation of the thing. But if we could demonstrate and show the improvements, we would like to do it with an actual router and an actual network, with state management also included in our project. Our our scope is for now limited to the CLI generation. But then to measure, you're right, the success metrics, to measure it, if it's after getting executed, if the changes is being reflected in the network, that will be our future scopes.
So one of the metrics that we plan to keep was the task completion rate, and also there is there would be one ideal template, right? So we are gonna compare it to that ideal template, and there would be a confidence score on how matching it is. And if it matches, that's how we improve on the model also. That's how we tend to make it better, the model.
I think you have to answer Ricardo's question with respect to your current implementation, right? Because he has seen your current implementation, right? So if you look at your current CLI template and what is output from the CLI commands, that capability itself, you can apply his question, right? So then you have to, for example, right? If I look at a set of human commands that you start with your dashboard, right? Your dashboard has a set of human commands.
Yes, sir. We have some suggested inputs.
And your output is a set of parameterized CLI commands.
Right, sir.
There itself you can apply Ricardo's command. That's what the real value is. You don't go look for a new problem and solve Ricardo's command. You apply his question right here. How would you do that? If you have a valid data set, for example, from human intents, and then corresponding valid CLI commands, YOS, Cisco, doesn't matter, Juniper, whatever it is. So a set of valid human intents corresponding validated CLI commands.
Right.
Then you can answer his question.
Yes, sir.
Yeah.
So, sir, basically our main aim is intent decomposition and CLI generation. So, intents will be very much in natural language, input parsing such that they are structured and can help us to convert those inputs into device level configurations. So, that is where NetSpeak comes in. Thank you, sir.
Hi team, just one question. Yeah, you said that the software takes part of CLI generation, intent decomposition and CLI generation, and then you execute those commands on the router.
Right, sir.
Suppose if some command gets wrong, it's not executed, do you roll back to the first step? Because this may change the behavior in between.
Sir, yes, sir, we'll include rollback mechanism. For now, whatever commands we generated are getting pushed and getting executed without any error prompts is the whole aim, like whole target.
How to check that whether if some error prompt is generated, that means the command is wrong, you need to roll back?
Yes, sir. We'll have to roll back and generate it again.
Okay, so please include that.
Yes.
Yes.
Thank you.
Yeah, that functionality you don't have now. It is
A
better
rollback
to,
mechanism.
Yeah, it's better to note down the NetSG's command, and then that agent is totally separate. That is again a closed loop agent that is separate.
Yes,
that will probably, the command is important because that closed loop will give you feedback to improve your data set.
Right.
Because it will give you exactly that KPI that Ricardo was asking, whether it did its job well.
Yes, sir. Yes.
Why it did not do its job well? Because the CLI failed.
Yes, sir. So it will be a closed loop, so we can add it as a feedback.
Actually, I think just a suggestion.
Yes, sir.
We should improve based on the feedback mechanism. Okay.
Right.
So suppose you are implementing something and you find some gap. So how to fill those gaps with feedback mechanism in next version?
Yes.
I think you have to identify the gap also.
Right,
You are the inventor, you have to identify the gap also, and you improve in the next version with feedback mechanism.
Yes,
How
sir.
to? That is my suggestion.
So,
Thank you.
Originally, actually, when we proposed the solution, we had this end-to-end solution. But then with iterations, we actually reached to this point because this is also one of the
major
application-
use case, like we
cases.
had a prominent use case. So we'll definitely note down including feedback and rollback mechanism along with extending it to multi-vendor support. We'll do
At
it.
the same time, latency also. So it should
Yes,
not
sir.
be repeated one again.
Yes, sir. Yes, sir.
Thank
Okay.
you.
Thank you, sir. Yes, sir. Yes, sir. True, sir. True. Thanks a lot, sir, for all your
Could you
inputs.
once again repeat the question that you had told? It slipped out. Yes, sir.
It was just to find a way to assess the quality of your tool. Okay, in case you would be challenged to compare your solution with the ones of somebody else, you could tell this the accuracy of the command generated or the speed of the command generated, some way to promote the quality of your results in terms of indicators, performance indicators.
Yes.
Yeah?
Right, sir.
Yes. Sir.
Thanks
Thank
a
you.
lot.
Thank you, everyone. Ma'am, will I sign out? Shall I sign out?
Thank you, Team SNR, for very nice presentation. Now I call upon No Wires Attached team.
I can't find my file. No, I'm under drive. Drive. No, actually, share as soon as you had given us a call, it was folders. No, here it is. But this side over here. And we have a big team to present. Yes. The drive, not docs. Just now it's right now, so yes, yes, yes. Here it is. Thank you.
So very good morning, ladies and gentlemen. Sorry for that delay. I'll just cover it up as soon as I can. So now, imagine this. You're in a remote Indian village, and the fiber optic cable that connects your community to the outside world is severed. There's a severe power fluctuation, your child's online classes freezes, and your teenage son who is studying for his end semester examinations, his internet access is cut down in his exam in the afternoon, which is a very real problem, by the way. It's like from personal experience. So imagine that. And then your bank app won't open, and nobody knows why. Now imagine that the network doesn't just detect the fault, but understands it, contextualizes it, and heals itself automatically, intelligently. That's the promise of what we've built. Now we present to you India's first AI-native multi-agent self-healing network prototype, designed for the rural backbone of our nation. Inspired by the digital divide we still face, and guided by ITU's vision for inclusive AI-native infrastructure, we built this not as a dream, but as a working reality. So why this problem? While urban areas are racing ahead with 5G and AI integrations, villages often struggle with basic broadband stability due to issues like power fluctuations, fiber cuts, and insufficient human resources to diagnose and resolve these issues in time. So we asked ourselves, can we bring the power of AI not just to optimize advanced networks, but to also make rural networks resilient and self-sufficient? That's how our concept of an explainable, AI-native, intent-based, self-healing network orchestrator was born, designed specifically for rural India, but scalable globally. So what problems are we solving? So fault delay detection and resolution in rural networks is delayed and it's costly. So implementation of our solution would ensure that these are fast, apt, accurate, and also cheap. So existing systems lack self-healing, contextual awareness, and coordination. So these are very redundant, as if they have human operators at the end who need to understand the issue and then fix it, which would waste a lot of time in valuable situations. So our system has 5 intelligent agents working in a harmony like organs in a body. The monitor agent senses live faults from NS3 simulations. The calculation agent, like a brain, predicts normal versus faulty metrics using LSTM, tuned via nature-inspired self-swarm optimization. The healing agent calls upon the Gemini LLM, in our case Gemini 1.5 Pro, retrieves contextual knowledge from an SQLite-based RAG-DB, and crafts personalized healing plans, just like a doctor with a memory or an intuition. And the orchestration agent, that's the important conductor, coordinating this symphony, ensuring harmony between detection, diagnosis, decision, deployment, and all this done using ZeroMQ, Tosca, and Xopera to convert plans into real, executable infrastructure healing actions. So how are we going to solve it? Multi-agent AI native framework, live anomaly detection by contextual healing and orchestration automation, focused on 2 test cases for this Delhi conference, that is power fluctuation and fiber cut. Now I'll be showing you a demo video and I'll walk you through everything from start to end on how this prototype actually works. You're in for a ride, ladies and gentlemen, so please, I hope I have your attention. So here are the logs that you can see. This is the very first step, is that you would introduce logs into the NS3 simulation, where it would show the degradation between, for example, if you divert your attention to the screen to the first line, it says degradation started, fiber cut between core A and core 1, so on. And it has different kinds of color coding available, from yellow, orange, and red, which increase as the severity in each of these nodes and faults increase. So with that, we start with the demo. Let me just quickly load it. Yep, so here we are. So there you see, ladies and gentlemen, is a beautiful symphony of all the nodes that we had created for especially mimicking the rural area network of India. So I'll tell you a brief information about what this actually you're seeing on your screens and why we have designed it in such a way. So it's a hybrid star mesh design, which is optimal for mimicking rural networks, and it has 85% local access to the internet and 10% community, which is inspired by the Cisco hierarchical 3-tier approach in 2002. Now why we have taken that, it's because it's better than the traditional 1D approach, and you are seeing a total of 50 nodes, and there are total 55 links that are connected to each. And in this, we have distributed them into different kinds of architecture. Like, for example, there are 5 core ones, which represents north, south, east, and west regions. And then they are further divided into a distribution layer, where they have 15 distribution towers, like kind of things, like in a region area or like a city, etc. And then you have the access layers, which are like 30. These could be your mobile phones, your laptops, or whatever. So as you can see in the video, these are now successfully communicating with each other, and this is how the simulation has been taking place. Now, as the time progresses, we have done a gradual fault injection using the logs that you have just seen earlier. And if you pay attention between core 0 and core 1, there's a yellow color coding that has changed, which basically indicates that the fiber cut has just been introduced, and the severity is still a little less. And then, as the time further progresses, and if the issue isn't resolved, even by humans, or it just goes unnoticed, then the color coding would keep changing. Now, as you can see, it has turned orange. The severity has increased. Now, pay attention to the distribution 2 node as well. At the bottom of the screen, it shows power fluctuation. There's a fiber cut between core 0 and core 1 for now, and there's a new problem that has been arised. So as you move on, these become red, meaning the severity has increased to the maximum scale, and it needs resolution immediately. And then access 0 here on the top left of your screen, even that has been facing a fiber cut issue, along with, which one is this? That is distribution 0, which you see, which just turned yellow. So now, moving further, let's discuss the actual code where the magic all happens. So here's the first agent, the first intelligent agent that I've spoken about, the monitoring agent. So what is the role of the monitoring agent exactly? So when you run the NS3 simulation, you actually get 12 files as an output, out of which there are 7 RAG SQL data files and 5 fault demo files, in which one is for topology and one is an XML file, which would be in charge for displaying the simulation that you just saw. Out of these, the monitoring agent would be getting 3 essential files. And what those files are, we'll be seeing in your screen shortly, that is there. These are the 3 essential files, that is network metrics, that is a CSV file for LSTM training, and fault events log for anomaly timeline, and then for configuring JSON for simulation parameters. So what this basically does is that it takes the fault test data of each of these nodes for LSTM training, so that when it goes to the calculation agent, the LSTM is trained in such a way that it can distinguish between faulty nodes and the real actual nodes which are normal. In that case, it will be able to explain why the fault has occurred, and it will also be able to understand how it has occurred. So this LSTM model training is essential, and hence the monitoring agent would access this and use it for training the LSTM. It would also be essential for SHAP explainability, which I'll get to shortly. So as you can see, the essential file state is it has read it, and then it has processed it, and at the end you can see there's an output of this monitoring agent, which is a .json file. And this .json file would be then communicating with the, moving forward with the calculation agent. So the calculation agent would now take this file, the .json file that has been provided by the monitoring agent, and then it would process the real-time data for each of these nodes. All 50 of these nodes would be processed. So the information inside the .json file would be 14 different features, that is throughput, latency, jitter, signal strength, voltage level, degradation level, power stability, so on and so forth. So it would communicate with this to the calculation agent via A2A protocol. And now as we get to the calculation agent, it would then use these and train the LSTM models. So it would get the details of all these nodes, and you can see the clear training that is happening based on the accuracy, the loss, and everything. And it would train all these models, and then it would gradually proceed further. Now at the end of it, it uses LSTM in coordination with a solved SORM optimizer. Like I had previously mentioned, it is used for detecting the learning rate and the different weights that have to be assigned. So LSTM uses the time series data to predict future values. So like I had mentioned previously, why this is important is because when fault is injected, how LSTM would recognize is that it would take the data from the faultless nodes, and then it would train itself to give a prediction on what would happen next. So if there is a deviation between this, as when a fault is introduced, and it would be a deviation in the prediction of what it had actually predicted. So what it would do is it would throw a reconstruction error to understand what is the amount of deviation that has happened and how much is the severity of this issue, which would then help us understand on how to deal with this situation further, or rather the healing agent, which would be coming to now. Oh, 1 second, let me run forward. Yep. So here we are, the next part, the healing agent. So now this is the heart of the entire problem statement that we had given, because we are aiming to make a self-healing AI orchestrated network. So now what this would do is that it would take the input from the calculation agent, analyze it, and develop a healing plan. So the healing agent and the calculation agent would communicate with each other with an MCP protocol. So here you could clearly see on your screens that there's a comprehensive healing plan generated, and there are different kinds of anomalies that have been received, or the different kinds of nodes that have been received for the duration. Then there's a confidence score that has been given on different probability values that it will see on how confident it is that this can be resolved. And there's a duration, and so there's a performance summary as well, where alerts received, healing plans generated, responses sent, and so on, with the different kinds of severity that you see on the screen. Furthermore, we would then go on to the orchestrator agent. From the healing agent, we would now moving on to the orchestration agent. So the healing agent would take the data, develop a healing plan, send it to the orchestration agent, which would then work with Tosca, and then develop a healing workflow as to how to be implemented. So this acts like a brain. It would understand what's to be done, and it would develop an idea. Now the implementation of it would be the responsibility of the orchestrator agent, which would be the responsibility of Tosca. Now what does Tosca do? It would take these files, the .json file that it has received from the previous agent, and convert into a machine-readable YAML format, so that the machine can understand what this is and send it to the Xopera, which is our open source orchestrator. So here you can see the orchestration agent, and the logs that you can see is that NS3 integration plan generated, then it generates an integration plan, Tosca implement template is generated, you can see the .yml file, and then the severities of each of these nodes. And then further, we can just skip forward, I guess. Yeah. So here we get to the other part. The other important part of our project is the explainability of it, as to understand, if you're a network operator, what exactly has gone wrong. So the AI can explain to you while it is developing a comprehensive healing plan for you to act upon, so it will save precious moments in times of crisis. So let me just explain what you're seeing on your screens here. So what SHAP-based explainability does is that we have taken the different 14 parameters that I have discussed earlier, throughput, latency, so on and so forth. And now based on the deviancy that it has different color codes for it, and it has plotted them accordingly. So red is for the maximum severity, yellow is for least severity. And it would understand which each of these parameters contribute the most to the anomaly. For example, in the 14 parameters, there are a few parameters that might be contributing the most to the anomaly that has been occurred. So that would be plotted in this. So the operator would understand what exactly is going on. So proceeding further. So here we are seeing the healing workflows that has been generated. So on your screen you can see the description, automated healing workflow execution, then there is an ID for the healing plan being executed with the string, so on and so forth. And over here now you can see healing plans received 6, Tosca templates generated 6, NS3 plans exported, that is 6, orchestration executions again 6, and it will also log any faults or any failure in operations, etc. So for now it's 0. And also shows the average processing time also. So in case in the next time similar kind of error kinds of occurs, then it would be beneficial to call back upon what it has previously implemented. It would constantly learn and apply. Proceeding now further. Just give me a second. Yep. So once that has been done and Xopera has received a comprehensive plan in the YAML format from Tosca, it would then be responsible for scaling it, applying it, and then effectively executing everything. So what it would do is that then it would at the end develop another JSON file. Now there would be a separate JSON file for each of these faulty nodes that has occurred. So it would have the different parameters and the healing action for each of these different nodes for each of the different problems. So now what it would do is that this file would be extracted. All these, in our case, there are 6 files, so 6 JSON files would be taken back to the NS3 simulation, and there it would be implemented. So you can see the healing here. In this format, now the cores have been returned to the normal functionality. There are no faulty nodes, there's no yellow, orange or red that's visible anywhere on the screen in the different kinds of layers that we had seen earlier. So this is the entire demo of how a self-healing network completely works with these kind of different intelligent smart agents that would not only just recognize but also understand and implement what they would try to do to reduce human effort and to also improve efficiency in times of crisis. So I'll just quickly get back to my presentation and I'll just wrap it up. I know I've taken a bit of time. So here we are. So finally, the technology is used. Like I mentioned earlier, there's the multi-agent architecture, the different kinds of agents that we have used. There's ZeroMQ, which would be fast and lightweight inter-agent messaging. And then the RAG with SQLite, which we are using for our knowledge databases, and Xopera plus Tosca. It's used, like I've mentioned, for infrastructure orchestration from AI plans, and the A2A protocol, which sends the initial alerts to the healing agent. So why is this AI native? That would beg the question, what makes this AI native? Under what context could this be classified as AI native? So AI native, by definition, would mean that something that not just uses AI, but also the AI is the core embedded function of the entire problem statement, that it is embedded into the DNA, which is what would make this AI native. So all the different kinds of structures that you have just seen, and at every stage where there are 3 different kinds of agents that have been produced on the screen, you could clearly see that it would effectively use AI to not just understand, but also explain as well as implement, which would make this a very core AI native solution. So here are the different code snippets that I would now like to explain to you. For the calculation agent, as you can see on the screen, it's a live metric analysis with the anomaly detection using sharp happens, and there's a ZeroMQ pub for stream of metrics, push for anomaly alerts, etc. Then you proceed forward with the code snippet for the healing agent, where it uses Gemini LLM with contextual database to propose healing actions, stores internal feedback, and pushes back to the MCP. Then the core orchestration agent runs all these agents concurrently async with ZeroMQ, coordinates NS3 simulation with inter-agent logic. And then the future scope plus conclusion, which is that the future scope for the which we will be implementing forward from this conference would be intent translation, power degradation, and false positives. So the future scope can be taken into expansion to 5G and 6G networks and disaster response. So ladies and gentlemen, what you've just witnessed is our entire work of around 4 weeks, where we have developed all these natively and by ourselves. So just to wrap up, I would like to say we had big ambitions, but we listened. We scaled back our scope for this demo, focusing on just 2 critical test cases, that is power fluctuation and fiber cut. The rest, intent translation and false positives, they remain on our roadmap like I've just explained. And now, ladies and gentlemen, what you see today is real. It works and it is ready to grow. This is the future of rural connectivity. This is AI native, and it's not just a buzzword. This is the driving engine, driving resilience, inclusion, and autonomy. You've just witnessed something special, something born for India, built for the world, and ready for tomorrow. Thank you, ladies and gentlemen. This is Team No Wires Attached, signing off. So before I would get to the questions, I would like to call my teammates up onto the dais to answer the questions.
Yeah, thank you so much, Team Wires, No Wires Attached. So thank you so much for delivering your this topic very clearly and very confidently. So I have 2 questions actually. You have taken 2 things, particularly power cut and media failure actually.
Fiber cut.
Yeah, fiber cut. But many a times what happens, there is no media cut, there is no power failure, but still traffic is not flowing. Maybe due to some IP issue or maybe due to some VPN issue. So have you thought of making your models to address these issues also? Number 1. Number 2, you are defining it for rural networks only. Will it not be applicable for any network, maybe urban network also?
So to answer your first question, sir, yes, we did think of it, but then the scope of the including the timeline and the scope, we had to reduce it down to these two solutions that could be implemented given the time frame of the build-a-thon. Because we as students, we actually had our end semester and other kinds of things that were going on parallelly. So we had deferred it to a future scope along with the 3 test cases. So when we proceed further after this build-a-thon, we would be working more on this, researching more on this, and developing a method to understand and introduce more data sets into our system so that we can effectively train our models to deal with all these problems. And also would like to mention one thing is that our software capability is broad. There is as long as the sensor data and the simulations are available for any of the network, which would answer your second question, it would be scalable globally as well. You can apply it anywhere that you would like to, as long as you have the data set available and the sensor values that you have. You would take it and put it in the calculation agent, it would understand what it's trying to do, it would then use the LLM models like Gemini in this case. So the application of this software is vast. What you've seen today is just a taste of what magnificence that this can bring. So in the future implementations, I promise you, it's going to be much better.
One more thing that I would like to add regarding the congestion is that we already have for this network in particular in the RAG database rerouting protocols. So we thought of like rerouting maps, and it actually does generate rerouting in case a fiber cut cannot be immediately resolved. Because again, it's a fiber cut, we don't know how it occurred in the first place. So it has rerouting like protocols in place so that the network can reroute instead of going through that particular line.
Yes, sir.
Thank you for the very interesting proof of concept. Actually, I think you stressed a point that is very relevant for the AI nativeness, which is the definition of agents. So you are splitting your system into agents. That is probably a very important point. So now my question is more on the design side of your work. So can you clarify what was the rationale for the definition of this very specific set of agents? For instance, you could have not defined the healing and the orchestrator agent as 2 separate ones, but it could have been a single one, for instance. So how did you come to this very specific definition of agents? Was there a reasons, a gain, or can you explain this point?
So there are 2 things. First, we thought of it like I had previously mentioned, like a human body. You know, there are different aspects and everything. So we drew a mental map on how we're going to implement it. And naturally, we got the inspiration from everything that we see around. That's humans and nature, like all other scientists do. So that's why we went forward with this. And the second technical benefit that we get is the different kinds of JSON files. Right? It makes the load on our processing systems easier. Because as students, we only have like laptops that we could use at our disposal. So given the tool sets that we had, the timeline that we had, as well as the inspiration from whatever we looked at around us, we had come up with this kind of plan where we had clearly defined each and every kind of agent instead of making it just one. I hope that answers your question if there's any follow-up.
Yes, it does, and I think it's a very good, how can I say, explanation. So as a suggestion for future evolution of your demo, of your concept, I think it could be very helpful to include a description of these reasons, because this could be very relevant for standardization activities. Standard bodies sometimes are debating on which is the best architectural setup or definition of elements, and sometimes is maybe a political decisions. So having some evidence like the reason why, from implementation perspective, that sets of agent was the most convenient, could be definitely enriching your solution, let's say your very specific solution. Thank you.
Thank you, sir. Any further questions, ladies and gentlemen?
Excuse me?
Yes,
I think same question, Mr. Ricardo, I think I was discussing with Vishnu, but you have already discussed. Our intention is to make the standard also, okay, and less number of agents. You have the monitoring agent, calculation agent, healing agent, and filing orchestration. So how to make the solution the standard one with less number of agents, that should be our target. But this is a suggestion from me.
Got it, sir. We will thoroughly look into it.
Hello team. Yes, one question regarding healing agent. Last row.
Hello, sir.
My question is around healing agent. You have taken healing agent is one of the important agent of your system.
Correct.
But have you studied the system actually like system errors, jitter, BER, and traffic congestion? So have you taken the system self-healing? How will it work self-healing? For example, some fiber cut is there. It is not self-healing thing. But some jitter error is there, that is self-healing thing. But you didn't explain well that how will it trigger the system to self-heal the error, system generated one.
Sir, to answer your question, thank you for asking that question. That would clear up a good point for all of us here. So what we have done right now is basically we have taken the 2 test cases that we could implement in a short amount of time. So what you had discussed would require data sets to train our models with, and that could be easily implemented once they are trained with such kind of anomalies like you have mentioned, like jitter rate or the signal strength has been been different, or the throughput is different. So that it would largely increase the data set on which we would need to train our models in, but it is definitely possible. So there will be a different thresholds that will be set for each of these once the data set has been trained by the AI itself. So the way it would do is basically it will send something called a 99th percentile threshold, which is basically it would analyze all these data sets and come to understand, like it will standardize it and basically understand which are the extremities of these kind of faults and where they lie. So based on that, it would develop a kind of severity index that we had just given a brief demo about, like in the different kinds of like from yellow to orange to red and so on. So once that has been implemented, then yes, we can definitely implement this kind of this thing and make it self-healing, because once the healing agent would make a comprehensive plan, at the end of the day, it would just go on to the LLM, which in this case is Gemini. So that would again help us generate another comprehensive plan, give it to Exopera, and then it would again introduce back into the system, and then you can see it self-heal. I hope that answered your question, sir.
Anirudh, I think the way to answer sir's question is that you have to look at it from what you're observing, right? So you cannot observe a fiber cut. You cannot observe a power cut because you're sitting far away. Rural network is rural network. Fiber can cut anywhere. You are not seeing the fiber, cutting like this. That's not happening, right? What are you observing? You're observing the logs, isn't it? Start from there. So you start from the logs, and there you go to fault detection model first. You go through the fault detection, then you realize, okay, this is because of fiber cut. How did you arrive at that decision, first of all? Because there is a fault detection model which is trained upon this. So you realize that there is a fiber cut or a power cut, whatever that is. So fault detection and analysis is the place where you have to start. You don't start with fiber cut and the power cut. Start with the symptom, right? When you go to a doctor, he starts with the symptom. Then another thing is you have to look at it layer wise, because like Ricardo is asking, you might see different faults in different layers. You might have to correlate them to find out really what is the problem. So these data sets that you are mentioning, right? That has to be the first starting point to train these models. Another problem in your presentation, what I saw, is that you're training real time. That's not a good idea. Training real time is not a good idea. That will take a lot of latency. You have to find another way to do it. You have to still simplify your number of agents. There is too many agents running around for your scope of things. I don't think that's a good idea. You should have the complete picture, but for Geneva or the next step, you should look at a simple structure of one data set. Pick the problem. Are you looking at fault detection? Then you pick the fault detection. If you're looking at healing, you pick healing. And then corresponding to that, you can look at, right now you start with JSON, then you go to monitoring agent, then you go to MCP, then you go to calculation agent, then you go to A2A, then you go to Tosca, YAML, then you go to orchestration agent. This whole thing and then you have problem because you have your students and you're not able to look at the entire thing. So basically you're manufacturing a problem. Don't manufacture the problem. Select, focus, and then look at the data sets and the corresponding solutions for it. Excellent presentation. Thank you very much.
Thank you, sir.
Thank you so much, sir.
Yes, sir. You had a question, sir? Oh.
Bogdan, go ahead, please.
Hello, can you hear me?
Yeah, we can hear you.
Oh, great, great. So first, I want to thank you very much for this interesting talk. It is interesting for me. And I would have a question, please. It is related to the choice of this zero MQ technology that you use for inter-agent communication. And if you could just summarize why did you choose this technology to make this communication? Is it independent from your network that you try to self-heal or for some other reason?
Hello, am I audible?
Yeah, you are.
So our thought process behind the whole thing was in one of our first mentoring sessions in this process, we had come to realize that SHAP itself, if run regularly, would drain would increase latency essentially. So we needed to find a protocol that would allow us to asynchronously kind of have the message transfer happen, and that was one of the reasons we came across like the
Zero MQ.
Yeah, MQ protocol. The other reason is because a lot of its files are incredibly accessible to us. So we were able to understand how it functions, and it was implementation-wise easier for us. So that's the two reasons. One is because the system is asynchronous, SHAP especially, and therefore the data that we send to healing agent and further on becomes asynchronous because of it. So we needed it for that. And the next is its open source nature. So that I hope that answers your question.
Okay, thank you very much. So if I understand well, it is related to these latency gains, right? That you get from using zero MQ. It is a better latency, like lower latency for this communication. And you mentioned asynchronous communication. So is it related to reliability of the system, scalability, or something like this? Okay. Okay.
Bogdan, as I understand, it is they are choosing it because of lightweight, open source, and asynchronous. These are what their explanations are.
Okay, okay. I think I understand, and thank for the speakers and to you also for answering. Thank you.
Thank you so much.
Any other questions, ladies and gentlemen? Okay. Thank you all for your time and attention. Jai Hind.
Thank you very much for your presentation. Team Celucast, you are the next one.
Yeah, good afternoon everyone present here. We are Team Celicast from RV College of Engineering, Bangalore, and we are pleased to present our project titled Intelligent Network Traffic Capacity Prediction for BTS, developed as a part of the FG AINN Buildathon 2025. Our team includes myself, Dr. Netravati, along with student Sagar Srivatsa, guided by industry mentor Mr. Rajat Dukkal from Nokia. Let me begin by highlighting the core challenge we aim to solve in modern 5G network. As we move towards to the 6G, BTS face highly unpredictable and dynamic traffic loads. These loads vary not just based on the time of data, but also at contextual factors like festival, weekend, and public event. Our objective was to build a solution that goes behind a conventional forecasting. We envision a fully AI native solution platform that is dynamic, context aware, and capable of handling in the real time to both the structure of the data and the changing network conditions. Unlike the traditional static models, our platform is adaptable to varied time series dataset. It performs dynamic model allocation based on the feature distribution, enabling it to select the most optimal model architecture in real time. Whether the data is periodic, spiky, or noisy, this flexibility ensures accurate prediction even as data characteristics shifts. Through this system, we not only predict future network load but also identify peak interval, helping telecom engineers proactively allocate resources and maintain quality of service across critical BTS location. Over to Sagar.
Thank you, Mom. So we developed an AI native intelligent network traffic prediction system to forecast traffic counters and help in better resource allocation at a network edge. So for the demonstration purpose, we have used two data sets in this setup. The first is transport dataset consisting of real-time simulated logs, including features like time, festival, weekend flags, representing backend transport level behavior. The second is RAN-based air interface data, synthetically generated using a defined mathematical relationship to emulate realistic radio parameters like CQI, SINR, and throughput counters. Although the nature of both dataset is different, one representing backend and the other radio level performance, both are inherently time series based, making them ideal for sequential modeling and forecasting. I'll go through the flowchart, the overview of it, and then we will go into one by one. So this is our system score workflow. This process begins with data ingestion. Once uploaded, the system cleans and pre-processes the data. Based on column signatures and patterns, it identifies the data format. So here in the case, we have used two, the transport and the RAN. Then it dynamically selects the best suited model from a predefined pool using a scoring strategy, which we're going to discuss in coming coming session. Yeah. So then it dynamically select the best suited model, and once a model is selected and loaded, we forecast the next N counters based on user input. After prediction, we can run a peak detection algorithm using the user defined interval and threshold. Finally, we trigger a powered LLM which analyzes the forecasted peaks and generate insights, assisting operators in decision making. So let's go one by one. What actually is inside our software, which is doing all these things at a real time. So talking about the signal processing part, which is very important, because as we know, before any modeling, the data undergoes several signal processing operations to remove noise and ensure it's fit for time series modeling. So we have adopted a lot of methods to do that. And we made this pipeline very much generic with respect to data sets. First one is outlier detection using G-score, where we remove any spike where the absolute G value exceeds the threshold. Second will be Fourier denoising. We transform the data to frequency domain using FFT, suppresses low noise, low energy frequency, and then reconstructs the clean signal. Then we have stationary noise removal using exponential moving averages. Then again, we have to handle the missing values, which we are handling through imputation using interpolation for small gaps. And again, the normalization to make it fit for the data training part and to get the results as fast as possible. And the last one is the windowing method, because we know this time series data have the temporal dependencies and which needed to capture. So we are defining the window range in order to capture it by making it very much variable based on the data set complexity, and it's on the user to set it. Now let's talk about what are the models we have in this framework. We have a range of deep learning and statistical models pre-trained on synthetic and real data. First is LSTM, GRU, and simple RNNs. As we all know, it is ideal for long sequence memory to remember those temporal dependencies and make the future prediction very much accurate. Then we have also have trained hybrid assembled models, which are stacking or averaging outputs from multiple networks. Then we have also introduced lag llama, LLM model, which is trained on all sort of time series data sets. Then again, Prophet. Facebook, it is basically belongs to Facebook, and this is very much good in terms of short-term predictions. And at the end, we have this Gemini LLM, who is based on the peak prediction. It will analyze the forecast output, and it basically tuned on one sort inference. So we give some sort of prompting in a way it should answer, and it will create it will create insights which is out of the prediction. So this is the models we have used. Now let's talk about, let's see, we know that in the data sets, it's not necessary one model is best, right? Like we know that for the controlled traffic congestions, we have a lot of models available outside, but all those are static approaches. Okay, so we wanted to come up with a solution where this dynamic modeling can be done based on the data sets, based on the features in it, based on the properties it has. So we have come up with this dynamic selection of models. Let me just explain you how it works. So this is our central part of our system, the dynamic model selector. Once pre-processing is complete, we extract features from the data, such as time-based features, as in day, hour, or it can be distributional statistics, mean, standard deviation, skewness, kurtosis. It can be FFT, frequency energy, which we can calculate it using this FFT. And then we can also have this trend and seasonality strength. So all these features are basically extracted. And for each model in our pool, we maintain a profile of expected input feature behavior. We compute a score using weighted feature similarity between the current data set and the model profile. The model with the highest compatibility score is selected. This method is kind of explainable AI, as we don't just pick models, we justify why the selected model best fits the data. Then comes the counter forecasting and peak detection. Because we are doing the resource allocation, we have to know what can be the future load so that we can allocate resources accordingly. So once the model is selected, we forecast the next encounters, again given by the user. For peak detection, we use this simple but effective algorithm. We choose this algorithm because it balances simplicity, speed, and interpretability while still being effective. It uses sliding window approach of size k on both sides of a point, again can be defined by the user, comparing the current value with the local maxima on both sides and then assigning the peak by annotating after getting prediction done by the selected model. So this is basically how the algorithm works. So you can go through it. Okay, so that comes the last part, which is the peak values and indices which are being passed to Gemini, a large language model. We have given some certain inferences to tell it, to give some insights out of it, and to instruct the operator so that it can help him in the decision making. So now we'll go through the live demo of it.
Now let's walk through a demo of our intelligent traffic prediction system, starting with a transport BTS log file. We begin by uploading the transport dataset using the file uploader in the sidebar. This dataset typically contains columns like date, time, weekend, festival, counter values. The user is then asked to specify two key inputs, which are the number of counters to be predicted and the peak interval. Let's say I put some 50 counters and at an interval of 5. And then I have other two options like sliding window steps and threshold. Let's keep the sliding window as 180 and threshold as 0.5. With this, the setting panel gets updated. Now, once the all inputs are set, the user clicks on Run Prediction. Behind the scenes, our system first performs data pre-processing such as denoising, normalization, and segmentation. Then, based on the dataset structure, it automatically detects the format as transport format. Next, the system evaluates different pre-trained models using a dynamic model scoring mechanism, and in this case selects hybrid ensemble, which is nothing but 2 layers of LSTM, 1 layer of RNN, and 1 layer of G based on the score, and the score is 0.72. Now, the prediction and peak detection process has started, and here are the plots. The RMSC for this model is 0.07, and this is the actual versus predicted plot, showing the model has captured all the temporal dependencies and able to predict. These are the next 50 predictions given by the user, which is appended after the previous counter values. And next is the detected peaks. As you can see, the peaks are detected at an interval of 5, represented by this blue annotation, and followed by the LLM analysis, which says the provided data shows that all 11 peaks exceeded the threshold of 0.50 and the average peak is 0.78. This strongly suggests that the license counter is under provision. Increasing the license counter is recommended to handle the observed demand and prevent potential future issues. So, this LLM-based analysis interprets the peak patterns and generates a narrative report that can guide network operators in proactive resource planning. Let's now try the same workflow using ranlog file. So we'll go here, we'll browse the file, and we'll select ranlog file. So we have uploaded a ranlog file which includes radio metrics such as CQI, SNIR, BLER, counters, and many other parameters. Now we'll enter the value for peak interval and counters as before. This time let's take interval as 15 and counters as 350. Keeping the same window, putting threshold, let's say 0.6, and let's click on Run Prediction. So it selected lag llama because the score is 0.74 and the format ran is detected successfully with an accuracy of 96%. So this is actual versus predicted plot. These are the 350 values which got appended with the previous ones, and these are the peaks which got predicted interval of 15, and these are the suggestions analysis done by LLM. Thank you.
So I will come to the conclusion. This system is AI native in two powerful ways. One is model agility and second is LLM integration. Why model agility? So instead of relying on the static architecture, this system dynamically selects the most suitable model that you have seen in a demo based on the data and the context, ensuring the optimal performance across the task, even that we have seen today. LLM integration, beyond the basic prediction, the system integrates with the Gemini, a large language model, the exact deep inside the support intelligent context aware decisions. This makes the system more robust and smart, and it is more actionable. So why this idea came in our mind? Because of it is very difficult to predict the operator what will happen in the next 2 weeks. So 14 days prediction we have started this model, and getting data from the operators is always challenge. So the radio part we analyze from the mathematical formula, we come up with the our own data sets, and the real data we have taken from the Nokia labs, which is for the transport prediction. So if we have transport prediction, we have radio prediction, and we have a core prediction, we can come up with the overall end-to-end prediction. How this is helping the prediction? When we have exams, network is slow. All the time network is working fine. When you need network, that time network is slow. Christmas wishes, network is slow. You want to go for the exam, CBSE online exam, open exams. Nowadays we have so many online exam, Swayam, Neptel exams. So all are, mostly the classes are online, but finally it is offline, the final exam. So that time we guys are facing challenges in the dense area. So during the sports festival or some other our own festivals, if we predict 14 days back and we reserve the hardware and software resources. When I say software resources, it means I'm talking about the licensing buying from the OEM. The operator should buy. Hardware resources is not a challenge nowadays. We are a completely telecom cloud, so we can enhance. We can request 15 days, 14 days in advance to the Nokia, Ericsson, or other OEMs. They can support, and you will get proper prediction and throughput on time. That was the intention behind this project. Thank you. And at last, I want to say thanks to DOT, our ITU department, and our guide, Mr. Vishnu. Thanks. Any question if you have, please? Yes, sir.
So this was a very beautiful presentation. You have considered every aspects, RAN aspects, transport and core, everything. But do you think that this will be most important during disaster? So how do you solve the problem when disaster is there, different type of disaster? So that time also the traffic goes very high sometimes, okay? So in that, suppose earthquake is there, something is there, so how to solve that?
Okay, so this problem is not, here we are not mixing the scope, but we have disaster management, so many cases in NPN, private networks, and NTN is also coming in 6G with the new solutions. But if you want a disaster management with this can be a separate model.
My question is, in that time traffic goes very high, okay? So suppose in Ahmedabad so the traffic goes very high that time. How to predict, since real time, normally that is the real time prediction almost, and how to allocate the resources and all, that is the.
Yeah, I think it's a very good use case. We should integrate with whatever we are doing. Once we get a data set is one challenge, but we can synthesize a data set with the help of Python or MATLAB, and we can work on this part. I think this is a very good real example.
And also I'd like to mention that currently we have these 5 models in pool, right? So, okay, so because in disaster we are relying on this particular software, so it should be firstly at real time it should answer you. And secondly, it should be really robust and give you very good accuracy. So with time, we can expand it by having more pre-trained model in the pool. And with this, as you see that whatever I did, I just uploaded a data set, and real time it has predicted and given you result. The same time it will reflected there. The best, what we can enhance here is basically add more pre-trained model in the pool that has better scoring methodology and will give more better results. And I think that can be useful in this such scenario where we need, Thank you.
Whatever the models you are taken from the other countries contest, the LSTM, GRU, whatever you have shown, I would taken the contest, Indian contest, how you analyze the data, how the relevance of the Indian contest, how you have changed you have said in between also, you have changed the modeling also as per requirement. What is the what the parameters you have taken in account while doing this modification? So with the contest is very important, because Indian contests are different from the developed original models. That is one portion. The other thing is the data sets, validation of the data sets, the accuracy and the relevance. How you have done it in this part? Because especially RAN part is concerned, your analysis on RAN is very crucial, because the RAN resources are very constrained, where your modeling should help the SOC centers to alert them and make it respond is very with no time. That is where value addition can carry. Your efforts will, how you are looked in this angle.
Yeah. So firstly, like the problem we are solving is basically those problems which are data set specific to time series first. Secondly, yeah, definitely we have this LSTM GRU model where you can see outside where these are trained and you're getting this particular predictions, right? But those are very much static in nature. Static in the sense, maybe one model, let's say LSTM, is working on one data set, but it's not, maybe another data set, some other model is better than that, right? So that problem will occur because what we wanted is at real time, you'll get the best model at the best accuracy possible, right? So what we did, what different we did is that, firstly when data set enters, so it goes through a signal processing pipeline where you see those denoising and all this imputation and all those happens. Okay, so we're removing all those things that fit the particular data set, fit for the model. That is one part that is always there. Secondly, the dynamic model selection, which we did, is the crucial one because we wanted whenever you do prediction at real time, we wanted it to be very much accurate. Okay, maybe where I'm using LSTM, I'm getting 92% accuracy, but maybe with GRU I can get 95, but I don't know, right? So to solve this issue, what I did, I kept some pre-trained models and took some like some large language models like Lag Llama and all, and Prophet powered by Facebook in my pool. Then how I decided, that's the novelty we have here. So basically we have certain parameters in the data set which have certain properties. Okay, we call it feature distribution, right? And those feature distributions should match the model. Let's suppose LSTM is, let's say I train LSTM with certain hyperparameters, right? Like we have gates and all, and we have activation function optimizers and loss, right? But those particular hyperparameters are applicable to a certain data set. So we trained particular models with that, and then have certain certain score defined. This particular model cell can work on a data set which has certain feature distribution. We are calculating the feature distribution of that particular incoming data, and if it is matching with that, closely matching with that pool, the models which are in the pool, then we'll choose that. The score you saw in the demos, the first is 0.72, 0.74. These are basically the score which is highly matched with that incoming data sets. And then the two models, first one we selected is the hybrid and second the Lag Llama. So other models also had given some score, but the score of these two are highest, that's why they are chosen. So that's how we are solving this problem, by making it dynamic in nature. I hope it answers.
Okay, thank you.
Thank you, sir.
Any other question?
Yeah, any other questions? Thank you so much. Thank you so much for providing this opportunity. I am very thankful to DOT. Thank you for Vishnu sir for giving so many guidance. Like without like I am saying, like usually like stay here patiently and listening to us, listening to our problems and helping us in modifying this part. So whatever result we have is basically result of that. So thank you very much, sir. And I will be very much thankful to DOT for providing us this opportunity to us to present our work. Thank you so much, guys. Thank you.
Thank you, Priksha ma'am.
Thank you.
Thank you very much for your presentation. Team SIGVision, you are next.
Yeah, so good afternoon everyone. We are team SIGVision from IIIT Bangalore. myself Kushagra Singh, my teammate Himanshu Khatri, and our mentor Rajat Dugal sir. And today we will be presenting our project Invisible Guard, a passive Wi-Fi sensing for smart border and building surveillance. I'll go through the objective of a project. Invisible Guard exemplifies a native AI application by leveraging passive Wi-Fi CSI data, eliminating the need for cameras or wearables to detect human presence invisible and non-intrusively. It processes raw signal features using lightweight deep learning models, example GRU, directly at the edge on the device like Raspberry Pi, enabling real-time privacy-preserving operations without cloud dependency. This sensorless, adaptive and low-power system aligns with native AI principles by integrating AI natively into the environment, continuously learning from the ambient data while ensuring ethical, scalable and autonomous development. I'll just go through the system workflow and I'll be explaining by the help of a flowchart. Yeah. So we have this Wi-Fi device, a regular Wi-Fi router or a device that sends and receives signal. Then we extract CSI. CSI extraction, so channel state information is collected. CSI contains detailed data about how Wi-Fi signals change when they pass through the environment, including people moving or all the activity recognition that we have. And we go through the pre-processing step. The raw CSI data is cleaned and formatted to remove noise and irrelevant information, making it ready for analysis. Then we have this time series windowing. CSI data is divided into small chunks, and over time, so this small chunks over time, so the model can process and motion pattern and like it can process all the motion patterns accurately. Then we have a deep learning model. These time windows are input into a deep learning model like CNN, LSTM, and the model learns to detect pattern associated with different human activities. In this case, we have 4 labeled classes, that is whether the room is empty, whether the person is standing, sitting or walking. And then it goes to the model and it recognizes, like it tries to recognize whether the activity is recognized or not, and if it recognizes, it just classifies as one of those class, and if it doesn't, it will just loop again for the whole thing. So now Himanshu will be explaining the pre-processing step.
So as you mentioned, we have 4 classes, which is one empty and second sit and third is stand and fourth is with walk. So the data set which we got from IEEE data port, we took that and from the 4 classes, we have from one PCAP file we have 1800 some packets, and from that we are making it windows of 150 packets, and then we take an overlapping of that 150 packets, and so making more of the data set use, and the training would be better, and to classify it will be helpful. So the major thing is that we in the 150 one packet we have 128 subcarriers. From that 128 subcarriers, we are taking only the data payload, which will have the CSI information, which will be helpful in classifying the human recognition, human activity recognition, and so that we are first making the pilot indices, null indices, and unchanged indices, and removing that from the 128 subcarriers, and only focusing on the 104. So here we have taken the from the first all the 150 packets, and all the 150 packets subcarrier 0, subcarrier 32, subcarrier 64, and plotted all these. We have plotted just the amplitude, not the phase or something. We have taken just the absolute value of the CSI, and for the training of the deep learning models also. Reading the first PCAP file, we have to remove the header of the PCAP files. So we have the first main function is to remove all the headers, and then moving forward for the main the main data payload structure. In the subcarriers of PCAP, we have minus 64 to 64, like 128 subcarriers. So we have changed that and remove all the null indices, and then just keeping the data payload subcarriers. And for the Python implementation, we have changed the indices from 0 to 104, like that. Then to remove the outliers from the data set, we have applied the Hempel filter. Basically, it does have a window of -3 to +3, and from the maximum 7, it calculates the local median, and then it from the calculation of threshold, if it's come greater than that, it will get removed, and the outliers will be detected.
Thank you very much for explaining your code, but one question, do you have 17 minutes long video?
Oh, no. We are just go through the main part of the code.
Okay.
So after removing the outliers, we making the data set more smooth so that we just get into the data which is actually important for human activity recognition. So from the low frequencies of the data, we are taking the threshold, which is calculating the sigma values, and then if it is lower than that value, it will be considered as 0, and if it's greater than that threshold, it will get the value which will be subtracted from the threshold. And after pre-processing, we have implemented SVM, random forest, and LSTM, by LSTM and by GRU. And these were the accuracies which we were getting, and the model which was best performing was the GRU bidirectional. From that, we were getting the best accuracy. Now, sir will discuss about the future scope and conclusion.
Yeah, so this document and the project serves as the fundamental guide for participation in the build of Thon 2025 organized by ITU, and it outlines key objective is to make native AI and introduce AI in telecommunication, including the development of AI pipelines, knowledge bases, AI agents, feature-specific application. By providing the structured example of POC, submission and implementation plan, this project and POC aims to the meaningful contribution towards advanced 5G and 6G. Now, next is channel impulse response, ISAC, so many further examples we can develop, POC we can develop, and it can be implemented with AI native networks. So with this, I would like to conclude that this is very good example for AI native. It can be embedded in the access points, and it can eradicate so many cameras. Even if I talk about this building, we have so many cameras, could be environment, hidden cameras. It can be eradicated with the signals. Signals can give the detection, the human activity, and what human activities. We have a different activity. We tried 4 activities, but we can extend to more based on the use cases and data sets if we get it. And it can really help in the private networks where I don't want to connect with the cloud and find out the disease in the cloud server. Second point is, first is it can completely remove all the cameras and give the solution through the radio networks. Second is channel impulse response is also one example which we can implement 5G or 6G millimeter wave. Once the PO is successfully done, we can go ahead for the next level, which will definitely help us for the 6G very first use case is ISAC. And this way, this is also very In a hospital system, the reporting of the patients, we cannot keep so many cameras inside the rooms, so many places, which is not ethically valid also. But we want to monitor the different positions of the patients. That can be also solved with this example, what POC we have demonstrated here. Thank you. Thanks DOT and ITO department. Thank you. If you have any question, please let us know.
Okay. I didn't understand. Actually, you are using CSI and all. So in camera, we have the true visuals. Okay. But I think in border area, this can be used for intrusion and all. That might be, in my opinion, that might be a good use case. But you can't replace camera with it because the quality of images will not be good. Even in 6G, we have integrated sensing and communication that is going to come. I think that sort of use case you are creating here. But what will be the best use case? That is important.
Okay. So when you talk about the border security, we can also implement, but only thing is, with this Wi-Fi, we will not get all the facilities. Along with 6G or 5G antennas, it is possible, which is also we have given in our papers that border security force. By mistake, we submitted only one paper. Second was a border security force. We missed that. We thought, okay, same we can serve, but we have added the line note here. And second use case is, everywhere we cannot put the camera. It's not valid ethically and cost effective. That can be solved with the signals. Just we want to observe the motion of the that particular zone or environment. And in case of mining, it can be a very good use case that we are studying. And we would like to come up next international conference, how we can solve the mining problems when there is a smoke detection or some other issues where cameras will not work, or there is some another issues, disaster management system where we cannot connect with the camera, or there is some issue because of the heat or the fire. That time it can serve the problem. That POC also we can take further based on the situation, channel condition, how the results are coming. That is also one motive. But first motive here, to keep the privacy, remove the camera and come up with some another solution with this channel reporting method.
But we must be clear with our use cases, because if we have good use cases, then only I think this will serve the purpose.
This we designed for hospital where patient monitoring can be observed in this use case.
Patient monitoring.
Yeah.
I think, Rajat, the problem is that here it requires a cooperative scheme. You need ambient UEs. That is the problem. So you need CSI. CSI comes from where? Right? CSI has to come from ambient UEs only. Means not the fellow you are tracking, the other fellows who are there. That is one of the problems. I think here it will be very nice if you concentrate on the data set and the integrated sensing part, what sir explained.
Yes.
That is the real use case. I think it will be good to concentrate on the data set. Yeah.
Fine. Thank you.
Thank you.
There is an online question from Marco. I am just reading for him. A question for invisible guards. You mentioned one specific model works better than others. Is it always the same model that works better for the different scenarios, types of activities?
So currently we have tried it on two different test cases. Like we had two different room setup, data set. So, and we came up with GRU working better in both the cases. Yeah. So in this case, GRU is performing better.
Marco, are you there online? It's fine.
Yes, I'm there. I mean, yes, I'm there. Can you hear me?
Yeah, we can hear you. Please go ahead.
Yeah. Thank you. Good afternoon. Good morning. So the point was that we saw before in the other team that we have a dynamic model selection based on the different scenarios, different type of transport or run. We can adapt the model. So the question here, in this type of scenario with activities by humans and so on, is there any possible use case where you see that the model may be not the same to be used, but depending on the data that you are seeing, different model may work and may be adapted? Thank you. Sorry for the quite high-level question. Thank you.
Yeah, here we can try with the different models and different data sets. The challenge here is to getting the data sets, and once we will search, because the time duration was very less for this the submission and this contest. So once we will have some, like, based on the feedback, we will try with the different use cases as well as the multiple data sets of different scenarios to cover the vast range of problem statements in this domain.
Thanks, great. So that's what I was expecting to see. Okay, thank you very much.
Thank you.
Interesting.
Thank you.
In fact, this model will work if you have more and more features of the data sets. So quality of your data set depends upon the successful running of this model. Training data set is very important. That is the crux of the solution.
So yes, we are doing offline training and then we are implementing into the field. Your question is, when data sets are increased, we need to fine tune the model based on that, and it's continuous learning process. So it's applicable for AML, any model.
Right.
Thank you. Thank you, sir. Any question?
Thank you, Team SIGVision, for a great presentation. Team SSN, the floor is yours.
Good afternoon, everyone. I am Syed, and we are team from SSN College of Engineering, Chennai. And I'm Syed, and these are my teammates, Shrikant and Prasanna. We all are fourth year students from EC, and our mentor is K3 ma'am. She's an associate professor from our college. So the title of our problem is 5G adaptive signal solutions for rapid transit and aerial operation. The thing that we are trying to do here is typically do beamforming, and this is a beamforming solution that we are coming up with. And we propose an adaptive beam steering algorithm, and this algorithm tracks down the user equipment and maximizes the received signal strength. So currently, in current 5G implementations, we have codebook based beamforming techniques. So the problem here is that in codebook, the beam is directed in all directions, and the beam which has the RSS is chosen, and that's the direction where the signal is sent. So the problem here is that a lot of energy is being wasted, and to improve the efficiency, there is a requirement of dynamic beam steering algorithm. So that's where we are proposing our solution. So this is our typical block diagram, where we have our fast-moving UE, that is the user equipment, and for here the base station is G node B, and this is the G node B is where the algorithm is implemented. So the G node B tries to maximize the RSS. So the point here that we are trying to do is make sure that the a half power beam width doesn't go below the 70% threshold, and our aim is to maximize the RSS. Our algorithm, our signal processing algorithm will be present in this particular module in the G-Node B. So that's where we'll be implementing our signal processing module as well as the AI ML engine. In the AI ML engine is where we will implement all our evolutionary algorithms or reinforcement learning algorithms. The intent of our problem is maximizing RSS. So the receive signal strength should be maximized. And how are we going to do? We are going to use a few evolutionary algorithms that we have tested right now, and we'll also use an RL technique to solve this problem. This is the flow diagram of our project. Here the user will have the config file, and he will get the scene from the OSM, and from there the digital twin, the important part of a simulator is Siona, and that will have the digital twin. The digital twin environment will be loaded from the OpenStreetMaps, and then we'll have the RAN simulator from the Siona, and this will give all the physical layer components to it. And we have done this simulation. We have successfully implemented the simulation, and we'll have the beam steering algorithm as a separate component, and this is where our algorithm will be implemented. So basically, this simulator will be having the user equipment as well as the base station, and here the user equipment is moving. So our intent is to maximize the RSS. So it's a fast moving object, can be a bullet train or drone. For now we have tested with a car, a moving linear motion, and then so this is what we are trying to do. We are trying to maximize the RSS even if the object is moving. So the feedback that we get from the user equipment is CSI. That's where we get our RSS, that is our received signal strength. So that's our way, that's the thing that we are trying to maximize. So our algorithm will make sure that the CSI or the RSS is maximized. How we are doing it is using evolutionary algorithms, and I'll come to it. And this output of our algorithm will be the beam angle. And this beam angle will be sent to the beam weight generator, and that will typically give us a beam weight. And this beam weight can be used for a simulator, and our base station would be able to direct the beam towards the user equipment. So I'll give this floor to Srikanth to explain the demo.
Hello all, I'm Srikanth. Since as my colleague explained how the intent of our solution, so I'll directly move on to the implementation part. So when we started, we didn't have a data set specifically suited for this case. So what we decided to have our own like evaluation environment which acts as a data set as well as a data set generator. So that's why we chose Shauna, so which has digital twin environments as well as physical layer and link layer components for simulation, for more accurate level of simulations. So yeah, so based on this diagram, so we'll be user will be configuring give his configuration as a YAML file. So in the YAML file, you'll be giving his scenes as well as the setup configurations like his transmitter configurations and receiver configurations and the positions, orientations, as well as the camera to view the scene. So since our aim is to track a moving mobile station. So in order to simulate that, the user also have to give the path data where the mobile station is moving, how the mobile station will move. So and also we have implemented two evolutionary algorithms. We implemented a modified version of genetic algorithm and particle swarm algorithm. So that algorithm choice is also given in this YAML. Or user also have the independence to implement their own algorithm also. So as a data generator, so this is a sample data set which contains the beam angles as well as the received signal strength and the channel state information such as channel impulse response. So yeah, so for simulations, as you see, this is the digital twin environment created by Shana. So since the video is actually not playing, but I'll explain what happens in the scene. So here the red color marker is actually the base station, and the blue color marker is the mobile station, which will be moving in the environment. Since the ultimate aim of the base station is to direct the beam and as well as to track the UV along inside the beam width, so to maximize the data rates, like by giving a maximum RSS. So we implemented the tracking using our, as I said, evolutionary algorithm GA. So we are improving it, but it's a sample output from the algorithm. So how it tracks and how it maximizes the signal strength, and yeah, this is how it tracked the directions throughout the timeline. So it tries to maximize the RSS like by taking the feedback from the user equipment, and it will predict the neighboring directions and evaluates all the possible beams and chooses the best one to direct the beam. So my colleague will explain more on to the algorithm we used.
So I'll give you the overall flow chart of what's happening here. First, initialization, we'll be having, initially we'll have our base station and the mobile station connected, and then the mobile station will be starting to move, and that's where our agent comes into action. So there's two possibilities. Either the beam is already focused and we're already getting the RSS, that way no problem, the thing is just fine. But in case if the RSS is dropping below a particular threshold value, our agent is triggered, and that is our evolutionary algorithm that we have tested right now. The evolutionary algorithm that we have worked is GA and particle swarm. There is genetic algorithm and particle swarm optimization, and this is how basically it works. First is we have to first find the points of consideration is the population here. The points will be selected, and we'll obtain the RSS from those points. And based on the points, we'll try to find out the maximum RSS in points which has the maximum RSS, and we'll try to exploit them. We'll try to move towards that direction. And in some cases, what happens is that direction doesn't give the our intent. So that way, we'll try to explore a few more cases. In our evolutionary algorithm, there is a mutation that's available. So we'll be able to induce some kind of randomness, and that randomness will be able to search more space. So that way, we'll able to identify whether the vehicle is moving in a particular direction or whether it's turning to a different direction. So that will be identified easily. And then this ratio has to be set up as to how much we have to exploit and how much to be explored. And after this ratio is set up and we are able to identify the optimum values for everything, our agent is able to obtain a new population, that is a new set of values, that is a new set of angles for the beam steering, and that is outputted to the user equipment, to the base station. And that way our RSS would be maximized. So this is the overall idea of our use case, and as future work we would like to propose that since we have used a tool called Sayona and we have a data set, we would like to publish this data set so that new members would be able to work on this. And also, for now we have tested on just one particular user equipment. We like to make more user equipments, like maybe bring out 5 user equipments, because that's how real life works. One base station is not just connected to one user equipment, it has many, and we'll work with that also. And we have also worked with reinforcement learning concepts, and we have implemented soft actor critic model, and that's also working well. We are yet to integrate it with Sayona, but it's basically all plug and play tools, so the algorithms, models can change dynamically. It's up to the user to choose the algorithm. So with this, I come to the end of my presentation. I'm open to questions. Yes, sir.
Beam steering techniques, okay, active antenna system by hybrid antenna, analog and that digital beam, and by shifting the phase of different antenna element, we can steer the beam. That is already there, and this is based on the RSI, even channel status information also, and we are trying to maximize in the direction of the UE. Okay, so what additional things you are doing here to have more this thing totally directional in UE, or UE is moving fast, because this is already there. So what additional or value addition you are doing here?
So it's just a start, but the main intent of our statement problem is like, since we have many parameters, like not only like beam angles, we have the power to extend the length of the beam, as well as we have the control of
see there we can make the beam directional, more directional.
Yeah.
Okay, that is already there. So
Yeah.
I think by the gain, in improving the gain of the antenna, making the pointed beam, we can extend the beam.
Yeah, extend, as well as by reducing the dimension of the array antenna, we can extend the width as well. But if you increase, it will narrow down. So we will have these much modifiable parameters, right? So if we have a model which has control to these parameters, we can dynamically adjust the beam shape as well as the angle as well as the length in a dynamic environment for the requirement from the environment, for based on the UV's movement, or based on the number of UVs. If a number of UVs clustered in a small place, means we can expand the beam width to cover all of them. So like that, like these kind of optimizations we can able to achieve.
Means simply you have to think the what is existing today,
Yeah,
and what you are expecting. So gap, if there is any gap, you fill those gap and do the value addition. That is, I think, requirement. Thank you.
Yeah, one question I have. Have you thought about the sensing properties which 6G is offering, 6G is supposed to offer to inculcate as a part of this? Where we are doing the sensing also. So sensing, we can understand the UE components availability with that, definitely. So have you done that anyway?
We haven't explored much on 6G cases now, but as long as we get more information from the UE, like environmental information, it will be better to point them out, like to get a better signal strength.
In our particular implementation, the input that we are getting is basically CSI. That's the matrix that we are getting. So with that, whatever information we are able to extract, we are working on that. Definitely, that's a good point to work on. Yeah. But for now, we are using the RSS, and our output will be the beam angle, the power, and as well as the antenna array. So that's what we have worked on for now, and we'll definitely try to incorporate that too, the sensing aspect as well. Thank you.
There are two online questions. One is from Professor James Agazo. I am reading that question. You can answer to him. How can evolutionary algorithms which rely on mutation and selection be integrated with machine learning, which typically requires large data sets to achieve dynamic beam forming? That is the first question.
Yes.
Second is from Mr. Paul Harvey. He is thanking you for the presentation and saying that given you experience with this work, what challenges do you see on integrating this in the current network technologies architecture?
Okay. So coming to the first question by James sir, this is a very common question as to how just mutation or crossover would work to provide QoS. For now, for our implementation, it definitely works because we have tested it really long. This is not a data set based testing that we're doing. We're doing offline learning kind of thing. I'm doing online kind of learning. That is learning from the environment. But I'm sure definitely the mutation and crossover is definitely not the correct idea to promise the quality of service. That's why we have tried to working on oral agents. So that way it will be more explainable. I will be able to explain as to why this beam shifted, why the power is maximized. So that kind of questions will be answered using oral agent. We are currently working on it. And we are, like I said, I'm working on soft actor critic model. And that way, that will be able to identify as to why I chose this particular beam and how I'm promising the QoS. That's definitely a valid point, and that's the reason why we changed from evolutionary algorithm to RL-based implementation. And for Paul Harvey question, do you want to answer?
And also I want to add on some more information on the first question. Like since we use the evolutionary algorithm as a start, since we don't have any data set, but we can use the same evolutionary algorithm to create the data set for even our deep learning models or deep RL models, we can train using the data that evolutionary algorithm computed. Since the main drawback is the evolutionary algorithm evaluates the beam many times, so it causes more delay. But using that, we can generate data sets to train DL models, which is more data set requiring, but as well as deep RL models, which will be more powerful, and it will be learning from the environment as well. So it's just the first step to use evolutionary algorithm. So
so in case of deep RL, we require a lot of data. So for that, we have to do first online learning, and that's where we'll use evolutionary algorithm. That way, I'll be able to collect data. I'll be able to understand the motion of the user equipment, and that way, I can make sure that my offline model also works well. So that's the reason that we are using evolutionary algorithm as well as RL, deep RL. And what was the question by Paul Harvey, sir?
Given your experience with this work, what challenges do you see on integrating this in the current network technologies architecture?
Yeah, there are a lot of challenges. One is definitely QoS, and the other is a lot of people are not willing to become open source. So where to implement this and how to implement in vendor-based system is also another challenge. And do you want to add on to a few more challenges? Yeah, so these are QoS is the main challenge that we are trying to address as to how we can promise the QoS and what metrics should be used for promising the QoS, and what policy should be used to promise the QoS is our main problem that we are trying to address. And that's the reason we have shifted to RL-based solutions. Is there any more questions?
Yeah, I think you should focus on the capturing the capabilities of the simulator given the use case. So you're taking one use case, right?
Yes,
so take that use case. For that use case, what are the simulator configurations and capabilities that you want to capture in the YAML? That should be your next step.
Yes, sir.
Because you are the best people who to experiment with the use case and find out what these parameters are.
Yes, sir. So that's also something that we're looking on, and how that's the next step, like how to publish the data sets, because we have now got a data set and we are confident about it. So that's also the next step, as to we can publish it, and we can also evaluate algorithms that we might develop in the future. So
what data set are you talking about?
The data set that we are able to generate using Sayona.
Right.
Because we are using online learning. Evolutionary algorithm is just able to learn and find out where the equipment is moving. So I can publish that data set, and maybe others can also contribute to it, and even I can also develop some algorithm to solve that problem. So
no,
yes,
that is nice, Syed, but for as far as this group is concerned, right, the focus group is concerned, the most important part is that configuration part. That is the most important.
Yes, sir. Yes, sir. We'll look into that also. So if there's any more questions,
Hello, Dr. Can I comment, please?
Yeah.
Hello.
Yeah, I'm able to hear you.
Okay. Thank you. Thank you for taking time to answer some of my concerns. And I was actually talking about how to use. Well, let me just make my submission quickly because of time. You said so much of it already. I'm thinking about using your evolution algorithm to optimize machine learning model parameters, architectures, or hyperparameters. Why am I saying this? The machine learning guided evolution algorithm will use machine learning to improve evolution algorithm performance, such as predicting fitness and functional functions or guiding search direction. So I think the combination of the two is good, but using it and probably combining them together is what the challenge might be, because most persons would want to ask if you're probably using evolution algorithm, the search and selection and mutation process might probably not completely fit it into what we're doing. But when you're bringing it together with the machine learning stuff, so combining both is actually fit. And at what point are you going to combine so that you can come about optimizing the evolution algorithm? So please is a technique that is worth going into. So please, as you advance into it, look for how to integrate the two properly and becomes a standard model. Thanks.
Yeah, that we'll definitely look into it. That's the immediate next step that we are planning on as to how to integrate the online learning and offline learning. So basically, sir was asking about how the evolutionary algorithm and the our ML model is going to be integrated. So that's our next step. That's definitely something we can look on, because we have worked separately. We have worked separately on evolutionary algorithm, worked separately on RL based implementation. We will kind of work on how to get the data from the evolutionary algorithm and implement it for the machine learning models. Yes, we'll definitely work towards that stream also. Yes, sir. So, yeah. If there are no questions, thank you for the opportunity, and I would like to thank Vishnu sir and DOT ITU for giving us this opportunity to stand here and present our project. Thank you.
Thank you very much, Team SSN, for your presentation. We will pause here for a break. Let's meet in 40 minutes, which is 12:15 IST. 40 minutes. I'm so sorry. Let's meet at 2:15 IST. TV for their presentation.
Good afternoon, everyone. Thank you for attending. We are from the team SPV and we are from Andhra Pradesh. So our team members include Miss Bhavana. Unfortunately, she was not able to come to New Delhi, and Mr. Ishwar from BNY Technologies, and myself, P. Prithvi Krishna. So let me tell about this use case. Actually, this document, what we are presenting, this is a submission report for the team SPV and towards Buildathon 2025 conducted in New Delhi during the third meeting for FG AI ANN. So I will hand over the use case introduction to Mr. Ishwar.
Yeah, hello everyone. So first of all, I would like to thank all our colleagues who presented very interestingly and thoughtfully. Unlike other technical presentations, we are taking a much more real-time use case, which is very common problem, but yet complex to solve, which is nothing but the curbing the fake news spreading in real-time society. So for that, we are proposing our solution Truth Shield, which helps us in preventing the fake news spreading by detecting the fake media which is circulating in the society. So you may get a doubt, like why is it important? Because there are many classifiers available in the market. Even there are many existing studies like telecom initiatives and other government entities which are already having classifiers. But just we want to highlight our model. We are taking multimodal data, it can access text data, image data, and verify whether it is authentic or not. And the second major factor of our model is it can have a combined rating system. While rating the article, whether it is relevant or fake, it consists of semantic similarity, text similarity, and even a recency score, like how much it is relevant with the query, like the date and the time. And even we are having an additional advantage, like we are checking the domain of the article with many websites like WHOIS, which checks the domain and latency of the article. And if a domain is having .edu or .org, like some official and government websites, we are weighting them more. So in this way, we are not just classifying the fake news, but we are verifying it. So let me walk through the architecture. Yes, coming to our architecture, there are mainly 3 layers existing. So when a user gives a claim, the data will be ingested and it undergoes some pre-processing by many other libraries like SpaceI, etc., where we get keywords and other stuff. So then the stuff will be going into the CDN layer. This is one of the crucial layers of our model. Here is the real life, where is the real data sits in. Like here, we are fetching the real-time data from the news APIs. So here sits the data in the CDN layer, and even for the caching purpose, it plays an important role in our model. So next, after the CDN layer, after fetching the data, we are moving to the application layer. This application layer is mainly termed as AI layer because we are using various AI models here for different purposes. We are using models like BERT, CLIP, BLIP, Gemini. We are using CLIP and BLIP for image purposes. I hope you all know that BLIP is used for image captioning and CLIP is used for image text similarity. So that when a user gives an image, right, if he only gives an image, the model can extract the text from the image and checks whether the given image is delivering correct news or not. Otherwise, if the case is like he gives an image and gives a caption, then the model checks whether the caption suits with the image, making the similarity check. So, and Gemini we are using here as fallout model. Like first we'll fetch the data from the real-time news articles using multiple APIs. But if there are untrusted articles, or if we get data from untrusted articles, or we cannot be able to fetch the real-time data from the articles, then we use Gemini as the fallout option. And after application layer, we are moving to the network layer with the verdict we got from the application layer using Twilio platform. It is a cloud communication platform where through APIs we'll send the claim to the model and user gets the verdict after processing through the API to network layer. The main thing we are expecting from the network layer is inference as a service. We want a smooth communication between the application layer and network layer so that it correctly triggers AI model and gives the correct verdict. And the second, one more thing we are expecting from the network layer is low latency so that it ensures quick prompts and responses. This ends our architecture. So just I want to go through the flow of our model. Yep. Let us say if a user gives a claim, just I'm considering a recent, like it's not recent, but a news article from the past. Like the input text is PV Sindhu won silver medal in Rio Olympics 2016. What happens first is the main keywords will be extracted here. Like the words Sindhu and Olympics Rio 2016. They will be extracted and captured. And the other main keyword which will be extracted is the date, which helps finding the recent articles relative to the claim. So after fetching all the keywords, we are fetching the articles related to it. So for this purpose, we are using News API and Google Search Custom API, which helps us in fetching the real-time data relative to the claim. So after fetching the articles, what we'll do is this semantic plus trust analysis. So there are several models existing which compares just the text, the user's claim in terms of text, like it will compare the similar words and it will give the verdict. But we are also including the semantic factor, like it reads the entire article and then it matches our claim with the article so that there will be no wrong verdicts based on meaning context. And other scoring logic, as I said before, we are considering other factors like recency score, like how much relevant is the article with the current context date of the claim. And the other one is trust scoring. As I said, based on the domain, we are giving the trust scoring. If it is a official sites or like the sites like org or edu, we are giving trust scoring. And the other one is, as I mentioned, the semantic scoring. So with all these factors, we are preparing combined score. And based on that, we are terming it as a confidence score of the verdict. So after getting the confidence score, here comes the final verification. Like if we are able to fetch multiple, like more than 2 or equal to 2 articles having the high similarity confidence score, then we'll give the verdict. Like if they are confirming the same verdict, multiple articles confirming the same verdict, then we'll give the verdict. Else we'll use Gemini as the fallout option. So this is one step like where we want to highlight also, like many existing systems are not using AI as a fallout option. They are just classifying it. So actually what I want to mention is also it is aligning with ITU T 5.3172 and 3173 standards, where it is a architecture with several data layers having AI used in it. So now just we want to move to the demonstration of our output. Yeah, you can see. Like there are multiple claims given here. The first claim I've given is Abdul Kalam is born in Tamil Nadu. The model have verified the claim and gave the confidence score as 1 because it is a fact which is known to many of us, like it's true. So it's gave a confidence score of 1. When we come to the second fact, interestingly, the International Telecommunication Union works on artificial intelligence native in telecom networks. Here it gave a bit tricky verdict, like it is mentioning that ITU's work includes initiatives related to AI in telecom, but AI native is generally a very broad term. So it is saying that it needs to verify whether it is happening on the broader perspective or not. And this is the text claim which we are verifying. Now I want to show our image claim also. So coming to the images, there are 3 ways we are checking the image. If we can see the image here, this is about the recent India and England test which is going to happen. So there is a news article came like there are many empty seats because Kohli retired. So the many seats are empty in England to watch a test match. So we gave the image. From that, it generated the text automatically that in first test match of England versus India, seats are empty due to Kohli's absence. So it generated the text, and also it is reasoning the text. It may need further verification because there would be many other factors other than Virat Kohli's retirement, because there may be some weather conditions or local influences which may be the reasons for the seats empty. So it gave the confidence score of 0.74, not fully confirming the factor that it's due to Kohli's absence. This is the case where we are only giving the image. Now the second case, we are giving the image with the caption, whether the caption is related with the image. For example, we may get several images in the news, and with that we'll get some captions like this is the recent incident happened like that. So whether to confirm whether this is the recent incident or not, we are using clip model here, which ensures the similarity between the text message and the image. So when we gave this to the model, it is giving the verdict that it is correct, it is a wishing message, and the text is matching with the image. So it is confirming the claim. And the last and final test for the image, if whether the image is real or AI generated. Nowadays, many deepfakes are increasing, right? For that, many forensic checks, etc. are happening. Here we are using error level analysis to check whether the image is AI generated or original. So when we gave the image to the model, we got the verdict that image may not be real. So in this way, like I want to confirm our system is multi-model data injecting, giving verdicts on a multi-data basis, which fetches the real-time news. So lastly, like I want to conclude my presentation with how our work is aligning with AI native. AI native generally terms as like it's not using AI as an additional feature, but building on the top of the AI. So how I want to justify our model as AI native is, we are having generative AI model in verdict decision making, which is Gemini. And the second factor I want to emphasize is we have shared AI pipeline, which helps us in multi-stage smooth processing of the data. And the third phase is like we are using multiple models, which contributes to the final verdict of the AI. So in this way, I can say that like our model is AI native. So yeah, thanks everyone. Thank you. Any questions? Any suggestions? Yeah. Yeah.
What is the kind of a confidence with which your model says that it's a your model says it's a fake image,
Yeah.
and suppose you use it on some other site,
Yeah.
and it says it's not a fake image. So how do you decide which one is true? Like, is there any benchmarking for these kind of a things?
Sorry, sir. Could you just repeat the question?
What I'm saying is, like you are saying that one of the feature kind of a thing was like looking at an image and saying whether it's a fake image or. Now, this is what your app or whatever feature that model is saying.
Yeah.
Suppose we take some other model and it says, suppose your thing says that it's a fake one, other model says it's not a fake one. So which one is true? How do we know that? Is there any kind of a benchmarking for that? Because I think there is a lot of evolvement is there in these kind of a things.
Actually, we used we used the legacy method, which is error level analysis, which is used in forensic checks. So it is already proven. So we have used that in our model. So I think that ensures the benchmark thing. It's already proven for the forensic analysis. It's being widely used, error level analysis. Yeah. Thank you. Thank you, everyone.
Ishwar, your network, I mean, what is the relationship with the network? So application space is very clear, but the network interface is that you have two mechanisms possible. One is inference as a service, and second is this kind of shared pipeline that you mentioned.
Yeah.
And then lastly also semantic networks.
Yeah.
These are the 3 points that will be important for us. That is the thing that is important for the group. So the application demo that you mentioned, that you showed, right? For that, what is it that you require from the network? Can the network help you to do better of this inference? That is the question. And how? There is the point. So if maybe, for example, it is possible that you have some models at the edge, which helps you to do this better. I don't know. I'm just
which
telling.
reduces latency.
Yeah. And not only reduce the latency, but also to do the regional content, for example. Right? That this kind of solutions are very good.
Yeah.
It has both the aspects. It has both the network aspects as well as AI aspect as well as application content. So this you have to design properly. Otherwise you will get questions saying that this is application space. We don't have to do anything.
Yes, sir. Actually, like as a future work, I want to develop it as a multilingual model. First thing, like regionally, based on the language and group culture and everything. The second thing is like if a particular message is being checked locally more times, then we want to forward it to local users so that it can prevent ambiguity between the people.
Yeah. Also, I think you also mentioned mixture of experts. That is a group of models.
Yeah.
That is also a good way to do it.
Yeah.
But this part has to be clear.
Yeah. Sure. Sir. Yeah. Thank you. Thank you. Thank you.
Thank you very much for your presentation. Team Omax, the floor is yours.
Good afternoon, everyone. We are Team Omax from SRM University, Andhra Pradesh. Myself, Sheikh Shaista Jebin, third year BTech student, and my mentor is Dr. Uday Shankar. He is chairman and CTO of Omax Technocraft, and he is assistant professor in SRM University, Andhra Pradesh. And other team member is Satibabu sir. He is a PhD scholar under Uday Shankar sir. Unfortunately, they both are not here due to some other works. With me, there is Prudvi Krishna. He is my senior from our university. He helped me throughout this work. So, I am going to present our use case. So, our abstract is like this is the document describes the topics and the sample submissions for the first edition to be conducted in the New Delhi during the third meeting of FGAINN. So first I'll start with the introduction. Like we may know that like our is a application based use case. Like whenever a person is alone in a house, he got some health emergency, but no one is in the house. Like if he's an old person or person who is working alone in other area, in urban areas especially, but no one is there for him to take to the hospital or get the treatment. In such situation, this application will help us a lot. So I will demonstrate it with this the help of this flow diagram. So we are basically creating an app with a person, a patient or person health records as well as with an emergency trigger button. So what is happening here? Let's consider a person who is staying alone in his home for work purpose or something. He came out of, he is staying alone. Then he have an app, emergency health app. So he in that app, all his records, health records along with the emergency trigger button, everything is there. So suddenly he got an health issue, but no, he can't call anyone like that. In that situation, he can just press the trigger button in that app. And then the trigger is broadcasted to the nearby hospitals as well as to the ambulances. So here we are using an machine learning model. Why we are using a machine learning model here is whenever a trigger, emergency trigger is whenever the emergency is triggered, then this machine learning model will take the all patient related data from the database, and it will use the data to predict any three possible diseases the person may be facing, and these three diseases are displayed on the dashboards of the ambulance and the hospitals. Then any one ambulance can accept the ride and it can go to the emergency location, just like Rapido or Ola we are using in our daily life. Here we'll use another machine learning model. Here we are using another machine learning model to have the optimized route from the ambulance location to the emergency location. So so that the ambulance will reach on time to the emergency location, it can take the patient to the hospital and patient get the treatment. So another thing here we are mentioning with the network layer, what we are doing is whenever the emergency signal is alerted, a separate network slice is allocated for the emergency signal, so that there is a less latency and the signal will be propagated fastly in the network layer. So for that purpose out of the list of topics given by the ITU, our use case falls in the AI pipeline to build and manage the enhancement in the network. So here we are enhancing the network for real-time emergency detection based on the patient data, route optimization based on the live traffic, as well as on the QoS aware communication handling for end-to-end network slicing using XApps. So other topic under which our use case lies is the AI pipelines for build and manage the future specific application. So here we are actually creating an application, emergency health app for predicting and monitoring the patient health, as well as finding the optimized route for the ambulance and prioritizing the emergency signal rather than the other signals. So once the person reaches the hospital, then again the network is normal. That means the network will get normalized after the person reaches the hospital. So I will demonstrate our work with the help of the video. For now, my work, I just designed a health prediction machine learning model, but I didn't go to the route optimization XApp because of the time constraint. Now, in the next ITU meetings, I'll show the other XApp and integration of both the XApps as well. So at present, I'm demonstrating the health prediction XApp. So here I took healthcare data set from the Kaggle, and I am using this neural network, GroupNet neural network, for predicting any three diseases. So it is a multi-class classification. It is not a single class classification. Why we are using multi-class classification? Because it is not like it is impossible to predict one disease. Person may not always get diagnosed with one disease. So our machine learning, our model will help us to predict any three diseases, so such that either one will be the true. This is our model, and we are converting our model into the ONNX format. Why we are converting into the ONNX format is like it is for the interoperability and portability. So use of ONNX format is like here we are creating the model, we are training it, testing it in the PyTorch framework. But if you convert it into the ONNX format, we can use it across any framework. So it is an interoperable, and we can use it for any type of hardware as well. If you want to integrate the sensors to know the patient real-time data like pulse and BP and sugar, other like that. Next, I'll show you how our dashboards are created for the doctor and the patient. At present, I'm not showing the ambulance dashboard because I'm not, as I already told, the XApp for the route optimization is not still done. So I'm showing the dashboard for the doctor and patient. So this is the authentication dashboard. Here we'll give the patient name as well as the password. For now, I kept password as the date of birth of the patient. Later, the patient can change the password according to their preference. So I am giving the person name and I am giving their password. we can press the login, and if you see, this is the patient dashboard. So the patient dashboard also have the patient information like his age, gender, blood type, all this. So whenever here we are using the MySQL database. So I took CSV file from the Kaggle, but we imported that into the MySQL database. The reason behind importing it into the MySQL database is like, so whenever I'll give name and the password, the query is sent to the MySQL database asking for this patient's information. So this patient information is displayed on the patient dashboard, and whenever the trigger is pressed by the patient, the predicted conditions as well as the medical recommendations, any of the medical recommendations it can, the model will provide. Then we'll see the dashboard of doctor dashboard. So doctor dashboard have a number of emergencies, like 33 emergencies like that. This is the recent emergency. So it is it is also giving the date and time when the emergency is triggered, as well as the predicted diseases and the what are the medical recommendations it can follow. Then this is our database consisting of patient information and everything. Okay, now we are converting our whole dashboard, like we used Flask application to create our dashboard, to run our models for testing and prediction, everything. So we are converting that Flask web application into the Docker. So we are dockerizing everything and we are deploying using the Xopera. So what is meant by dockerizing is like containerizing the whole, like we are creating containers for web application, for SQL database, for message triggering and all that. Why? Because for the isolation and for the portability and interoperability and deployment. So then we are, after dockerizing it, I am deploying it using the Xopera. So this is the same file which we are using, and I am deploying it. After deploying, so first we are building the Docker, and we'll check if the all containers are running or not. Here we have 3 containers. So we have the web app container, MySQL container, and Redis container. So web app container is for the interfaces and all that. MySQL container is for the database, and the last Redis container is for the when message traveling from one interface to the another interface. And then after running, we can see the same output we saw in the Flask web app, like in PyCharm, which I run before. So after we are deploying it with the Xopera, again we are getting the all links for the authentication dashboard, doctor dashboard, and patient dashboard, and you can log in with any of, you can open any of these links, and you can again go to the web application that I already showed you. So again we are going to this same flow. So that's all. And why this is AI native, I want to explain why this is AI native. We are dockerizing our AI model and we are deploying it with the Xopera. So doing this make it interoperable and portable, and it can adapt to the changes. So it is satisfying the promise of AI native system, like adapting for the dynamic changes. So, and I also mentioned that we'll allocate the network slice. Network slice is also based on the emergency signal. That means we are going to the network layer, and network slice is allocated whenever the emergency signal is coming. Like we don't know when it will come. So that is like the network slice is allocated based on dynamically. We can't predict. So it is completely dynamically based, and that's it from my side. If there is any suggestions or comments.
Just to add on a point, where is the document? So this use case we developed considering three things in the mind. One is AI native networks, and one is ITU standards, and with reference with ORAN, which is the hot topic in telecom. So considering these aspects, like we considered ITU-T Y.3172 as a ITU standard, as well as Y.3176 with the ITU references, as well as the ORAN concept, where Exopera or as OAIC, these things. And I really thank you, Department of Telecommunications (DOT), for organizing this event, making us physically present here, and ITU International Telecommunication Union for this wonderful opportunity, as well as Mr. Vishnuram sir and Dr. Preksha ma'am for our mentoring sessions. Thank you.
Any questions or suggestions, please? Yeah.
Thank you very much. Very interesting. Actually, I have two comments. The first one is I appreciated that in this proof of concept, you were actually at the same time combining the usage of AI, both on the application level for aiding the doctor tasks and for the network side for ensuring the quality of service as the ambulance is driving. Which is good, because that smells native in my view, because it's really layering AI everywhere. What I found a bit missing in the description is actually how and if these two AI parts are interacting with each other. If there is any interaction or any need for having these two AI components glued together, or if they are just two different demos. That was the first comment that I would ask if you could clarify, or maybe for further evolution of the activity. The second comment actually is a challenge for you, I would say, because the use case is very relevant, and we know that we do not know where an accident may happen, and we do not know where the hospital will be. So you have no clue where the ambulance will have to drive. Now, if you design a solution that is bound to some specific access network technology, you may be challenged that your solution will be discontinued as soon as the ambulance is driving wherever it shouldn't be. So in this case, the suggestion or the challenge would be to tune your activity to make it access agnostic, right? So you don't know where the hospital is, and you want to ensure that wherever the ambulance is driving, rural area, hotspot, even Wi-Fi coverage, then could work. If you make your solution and your orchestration action or the action on the network bound to a specific standard or a specific access, then maybe the patients won't be happy. These are my two comments.
Okay. Thank you for the comments, sir. And interaction of two AML models which you asked, we are working on it. In the next ITU meeting, I'll demonstrate both the models along with the interaction between them.
Yeah, I think I will slightly generalize Ricardo's comment. Not only models, you have to look at entire pipeline.
Okay.
So, for example, some part of the pipeline may be in one domain, another part may be moving, like Ricardo
ambulance.
said. Yeah. So, for example, data source may be moving, or inference sync may be moving. That depends. So you have to think of it that way. And another thing is. Data sharing and knowledge-based sharing, I think we already discussed. You need to be very clear what are the interfaces needed from the network. Just any application space, like we discussed with the issue, same thing. What are the interfaces required from the network side has to be clear. For example, the same edge can be there. This kind of mobility aspects can be there. Whatever that is, you have to explain that part.
Okay.
Thank you.
Thank you so much, sir.
We noted down the comments and we will work on it.
Thank you for the suggestions and comments.
Thank you very much. Our last but not the least team is a remote team, Tech Rangers. Please raise your hand to take the floor.
Israel, are you there? Israel, are you there online?
Yes, please. Am I audible,
You
please?
can, yes, we can hear you very well. Please
All
share your
right.
screen and go ahead.
Okay. So, good morning, good afternoon, good evening, everyone. My name is Israel from Nigeria, representing the Tech Rangers team from Nigeria Federal University of Technology. I am here on the platform with my team members and our mentor in person of Professor James Agajo. And the title of our solution is using AI to reduce 6G standard barrier for African contributors. Or simply put, an AI native solution to 6G standard barrier reduction for African contributors. So in just a bit, I'll be sharing my screen to present an implementation demonstration for our solution. But for the sake of context, I would just like to give a brief scope to motivate the problem we are addressing and how we are solving it. So it is fact that the world is tending towards 6G with promising things like almost zero lag, built-in AI everywhere, and very fast download speed. But it makes to make these promises real for everyone, we need a very fair and inclusive rule, which should also be African inclusive, hence our solution. So when African engineers and researchers cannot contribute significantly, they stay on the sideline. And if 6G standards do not reflect African needs, by that I mean consideration for places with spotty power, grid, tight budget, and even scattered infrastructure, then the next generation of network scope will leave large part of the continent behind again. So from a very holistic standpoint, our solution is an AI native multi-agent platform that analyzes 6G drafts for regional gaps, assists in draft writing, verifying compliance amendment proposal, and providing a conversational RAG power chatbot to guide African contributors through the standardization process. So hence our demo presentation today, we had focused on bringing the later to reality. By the later, I mean the conversational RAG power chatbot guiding African contributors through the standardization process. So permit me just a few seconds to share my screen, please. Okay, is it visible, please?
Yes, Israel, we can see it.
Hello everyone. Good.
We can hear you. We can hear you.
Okay, thank you.
Day. My name is Frank Abeladiki, and I'm a member of the Tech Rangers team. And in today's demo, I'll be showing you one yet very important component of our broader AI native solution, the training agent. This agent functions as a chatbot designed to help new and underrepresented contributors, especially from Africa, to be able to understand and navigate the complex ITU-T 6G standards. Now, while this full system includes autonomous agents for gap detection, standards drafting, and compliance checking, this demonstration focuses solely on the training and knowledge delivery aspect, which is essential for onboarding new participants. And the flow of this system is such that we have the user, and then he interacts with the chat UI, and then there's an AI agent behind the scene. In this case, I'll be using the Anything LLM agent, and then we have vector searching, and then once a response is generated, it's then fed back to the user. And to be able to achieve something like this, the first thing we did was to upload our standards document. And this document, we are ITU standards documents, which were carefully selected based on their topic relating to 5G, 6G, autonomous networks, and artificial intelligence, and so on. Now, before these documents were uploaded, we had to configure how the embedding was to be done. The embedder that we chose was actually the Anything LLM embedder, which is the All Mini LM L6 V2 model. And then we also had to set up the text chunk size, which in this case we set it to be 1000, and then the text chunk overlap, which in this case we set it to be 20. Now, having done all this, we also had to set up the database where the embeddings was to be stored. And in this case, we're using Pinecone, and then we set up the index name. And if you check over at my Pinecone database over here, having embedded the 5 documents, we had a total of 871 embeddings. Now, it's also worth pointing out that this knowledge base that we have over here contains basically ITU standards document, and this document will be elaborated for more capabilities later on. Now, moving on back, having set up a vector database, we also had to set up the LLM. In this case, we're using the Gemini 2.0 Flash, and then we provided our API key for the systems to be able to interact. Now, having done all this, I'll show you how to interact with this system. I have prepared a couple of questions to be able to test this out. So I'll start with this one. And then all this, the response is basically that this system will be generating for us are based on our documents, are based on the standards document. And since that we have implemented a RAG system here, most of our interactions with this particular system are being stored to be used later on as we continue to interact with it. And as you can see, it has given us a response, which it's basically cited from the document. I'm going to ask it another question. And all of these questions are regarding standardization. Okay, and then now it has given me a response, and then it tells me where all of these documents are gotten from. And then I'm going to ask it one last question that regards me triggering the AI agent. And so we can see that the AI agent is started, and then it's loading, reading my information, and then it's providing me a response. And as you can see, all of the responses that it provides for me are all from the ITU standards document, which I have embedded and then connected to this system. And so in conclusion, our AI native agentic chatbot is designed such that it lowers knowledge and accessibility barriers to entry by making these complex 6G standards accessible through natural conversation. This is designed such that it empowers African contributors to be able to engage confidently in global standardization and also participate as well with context-aware and standards-aligned guidance. Now, to answer the question of how is our solution related to AI native networks? Now, I would say that our solution is truly AI native because at its core lies an extensible and semantically extended knowledge base that functions as a semantic orchestrator. Now, it not only enables deep contextual understanding and intelligent reasoning, but also serves as the central foundation upon which multiple autonomous agents and tools can operate in coordination. In our use case, this shared knowledge core ensures that each component within the network, which is from training to gap analysis and standards compliance, assesses a unified and structured source of truth, enabling coherent, scalable, and intelligent collaboration across the entire AI-driven system. All right, then, thank you very much.
Okay, thank you very much, please. That is the presentation. We're open to feedback, comments, and questions, please. Thank you.
We have one question from Marco.
Yeah, thanks, Preksha, and thanks for this. I think every topic which technically try to improve and improve the issues of standardization gap and training and knowledge sharing is very good. But I have a question at the beginning. Even in the title, you talk about helping African contributors. And my understanding was that you wanted also with this tool to help to match standards, arena, standardization, documentation, current standards with respect to what could be regional requirements, regional gaps, and so on. So I saw more in the presentation what is inquiring from somebody that want to know what the standard is able to do. And so I'm asking a question to the standard. I would like to do this, how the standard can answer that. But you don't have in this LLM database the way to identify if specific requirements, for example, or maybe a potential gap that you see from your region is addressed, investigated across the different standards that are considered in that space. Thank you. So more as, yeah, I hope it's clear what I'm asking. Thank you.
Okay. I guess I get a bit of it. So this might fix it. So I think the question has to do with how do we go about gap identification, basically. Am I right, please?
Said at the beginning, I have requirements. I wanted to meet to analyze how we can these standards can meet the regional requirements, regional gaps, right? So I was understanding from that point of view that you are discussing new technology, you have requirement for some application, for example, in a given African region, and you want to say the standards today can match this requirement, or we need to do more. Thank you.
Okay, I'm sorry, I didn't get the question. It sounds to me more as a comment.
Israel, let me take that. Thank you very much. Marco,
Okay.
I think there is a small gap in your question, I think. So I think, you know, the knowledge base and the chatbot, there are two aspects to Israel's solution. One is the knowledge base and second is the chatbot. The chatbot helps the contributors to answer questions related to the standard. That is a basic solution. In one line, that is a solution. So now, the more documents you parse and create the knowledge base, the more powerful the solution is. I believe, as Frank explained in the video, I think they are taking a couple of documents and doing this as a prototype. They are explaining it. This will not do the gap analysis for you. I think you are reminded of Fujian's solution. I understand that, but that will not do the gap analysis for you. That is not the intention of Israel's solution also. I think, however, I know what you're talking about. So the way to achieve that is to analyze the knowledge base. So the back end of Israel's solution is the knowledge base. So if you analyze the knowledge base, you can actually come up with gaps. That is possible. But I don't think Israel is focusing on that aspect. So I don't think he can answer that question. However, I think knowledge base is very valuable. Yeah, knowledge base is very valuable. It can serve as backend for this kind of gap analysis that you are pointing to. I would request Israel to please take note of it.
Definitely, sure, sir.
With this, we have been through all the presentations of Build-a-thon. Thank you very much to all the teams.
Good evening and welcome all our esteemed dignitaries, respected duty officers, distinguished guests, and participants gathered here for the prize distribution and concluding ceremony of the third meeting of FGAINN and Buildathon. Today we are specially honored to have with us Srimati Tripti Saxena, Senior DDG and Head, TEC, whose guidance throughout this event added immense significance to this occasion. I welcome our esteemed guest, Sri Rajkumar Upadhyay, CEO, CDOT, and Sri Dipesh Srivastav, AVP Tejas Networks. I also extend warm welcome to Sri Vishnu, Mentor ITU, and Ms. Preksha, Research Scientist, IIT Bombay, and Chair of Working Group 4 of Focus Group on AINN, and all the respected mentors, esteemed jury members, distinguished delegates from DUT, industry and academia, and of course our brilliant participants. Before we proceed with the prize distribution for the winners, we have a special video message for all the participants from Mr. Shizu One, Director, TSB ITU. Let's take a moment to hear his word of guidance.
Welcome everyone to this truly special prize giving ceremony, a moment that marks the remarkable conclusion of the FGAI Native Networks Buildathon. Welcome everyone to this truly special prize giving ceremony, a moment that marks the remarkable conclusion of the FGAI Native Networks Buildathon here in vibrant New Delhi. This Buildathon, launched in partnership with the ITU AI ML Challenge, stands as a flagship initiative of the ITU-T Focus Group on AI Native Networks. It embodies our shared commitment to fostering innovation and creating real impactful solutions for the next generation of networks. Over these past weeks, we have witnessed incredible dedication with participants diving into intensive online mentoring, culminating in 2 unforgettable days of the hands-on collaboration, creativity, and breakthrough ideas right here in New Delhi. But this event is so much more than a competition. It is a living proof that when global minds unite, guided by mentorship and driven by youthful passion, we can shape the future of AI native networks together. To every team, I salute your hard work, your perseverance, and your bold, innovative spirit. And to our mentors and organizers, thank you from the bottom of my heart. Your unwavering support and dedication have been the cornerstone of this event's success. Let this be just a beginning. Together, we are building a future one idea at a time.
Thank you for your encouraging words, sir. Now I welcome all the dignitaries on the dais. Senior DDG and Head Srimati Tripti Saxena, ma'am, please. Rajkumar Upadhyay, sir, CEO, CDOT. Shri Dipesh Srivastava, AVP, Tejas Networks, Shri Vishnu Ram Ovi, ITU Mentor, and Ms. Preksha, Senior Research Scientist from IIT Bombay. Now, I take this opportunity to express our sincere gratitude to CDOT and Tejas Network for their invaluable support to this Buildathon event. I am pleased to invite Shri Dipesh Srivastava, AVP, Tejas Networks on stage for sharing few words.
Hello, am I audible? Okay, so basically first I would like to thank TC, I would like to thank DOT and I2T for organizing this event. And this like Buildathon is a like very novel event, spanning across 5 sessions starting from 23rd of May and finally concluding today. And I am fortunate to be among the, I would say, top mind or best mind in this ecosystem actually. Right now, with the current ecosystem, and I would say supported by the government of India and across various private houses actually, we are in the best era of India to make changes and affect changes. 5G as a technology, 5G as a stack, indigenous stack, that is something which has caught the attention of the world from the India. I would say this is something which has been made possible by the government of India, by the DOT, through where actually the opportunity has been given to Tejas, CDOT and TCS to come up with a complete 4G, 5G stack out of India. And that is something which has I would say accelerated this whole ecosystem. Right now, when we talk about this AI is AI native networks. That is something which is a buzzword and need of the hour. With more and more data getting pumped, therefore, we require optimization in terms of the number of the sites, in terms of the energy consumption, in terms of lot of optimization parameters. So that is something. So you guys, I would say, are in the right place at the right time, and we together will make a difference. I would like to conclude this short thing with a small shloka in Gita actually, where we say, Karmanya vadikaraste ma phaleshu kadachana ma karm phal hetur brahma te sango astva karmari, which means we have a right to work, but we do not work with the result of that what we are doing we are going to achieve. And that is something you guys are doing and we are doing actually to affect the changes. We are making small steps towards the same actually, and things are happening and things are making difference. Thank you.
Thank you, Dipeshji, for your encouraging words. I now invite Sri Rajkumar Upadhyay, CEO CDOT, to join us on stage to address this gathering.
Good afternoon, everyone. Madam Saxena ma'am, my other experts on the dais, dignitaries of the dais, participants, winners, ladies and gentlemen. First of all, I would like to thank TC and ITUT AI focus group to invite me to give a talk on this. Last 3 days would have been very, very useful, very, very successful, where a lot of talks and workshops have happened on AI/ML, next generation wireless networks, AI and computational support for new use cases for 6G, foundational AI models in telecom systems, and many more. I'm sure, I'm told that the event witnessed very good participation for academia, from the industry, from the startup ecosystem, and definitely, it will pave the way for what we are looking for going forward for AI native networks in telecom networks. We all know that AI has become already part of critical part and parcel of our daily lives, and definitely its use in the telecom network is very much warranted. Um, uh, and AI in native networks, or AINN as we call it, is shift from using AI as an add-on tool to embedding it deeply within the network fabric. Till 4G, 5G, I think whatever AI we are building is we are building outside to do this, and going forward, because 6G will be the AI native network, and therefore this focus group, a lot of hope is there from the focus group that a lot of these inputs of focus group will go in designing the technologies for 6G, for which the standards are getting made. We know that India is also taking a lot of steps in terms of taking AI forward. We know that the global AI market for network is projected to reach USD 46.8 billion by 2029 with a CAGR of 33.8%. NVIDIA's study of last year shows that 89% of the telecom operators are either piloting the AI or actually using it, and 41% has actually actively deployed AI into their networks to solve a lot of problems of the network and the customers. We in India have, a lot of happenings is taking place in AI. For example, you would have read very recently or yesterday, TCS and NVIDIA has signed an, agreement to collaborate in design AI native solution for telecom sector. As Deepesh was saying, that we have become the 5th nation in the world to develop our own 4G and 5G technology, and TCS, Tejas, and CDOT have together built this. And I must say, as part of this project, TCS has built a system called CNOPS, Centralized Network Operations Center, which is fully AI based, which actually collects the alarms, logs from the various part of the network, and is able to do some predictive analysis in terms of failures, in terms of analyzing the traffic, in terms of analyzing the behaviors of the node, and therefore the same experience, I think, going forward, because India is working very hard to in 6G technology, because we actually missed the bus in 4G, 5G initially, but we caught up with the world, and today we have our own system. Going forward, when we design 6G, these experiences of developing CNOPS or the whatever AI we have used in our designing our 4G and 5G will be used in the 6G network. You also know that Government of India has launched Bharat Gen, which is multimodal, multilingual large language model initiative that has been designed to develop AI solution for Indian language and culture. India is also establishing country's first AI special economic zone in Naya Raipur, Chhattisgarh, with 1,000 crore worth of investment to foster AI innovation, including telecom specific application, by creating a hub for research development and deployment. Under the AI mission, Government of India has procured 15,000 GPUs, which will serve the base for our startups and ecosystem to take this infrastructure and develop various solutions, because we know that startups and everybody cannot make that kind of investment. The Government of India has made this investment to make the AI infrastructure ready, so that our startups and ecosystems can actually develop their applications and use cases in this infrastructure. We in CDOT also have been working very actively in AI. Primarily, our AI solutions are based on the need, what we felt. For example, we know that there are a lot of cyber frauds which were reported in the country, so we developed a solution called Fraud Pro, which is typically called Astra, wherein we use AI and ML to find out which are the fraudulent connections in the network. You all know that we have launched, DOT has launched, which we developed as from CDOT, Sanchar Sathi portal, Sanchar Sathi app. So Sanchar Sathi is citizen facing as well as it is connected to law enforcement agencies, banks, WhatsApp, so that whenever it is crowdsourcing the data from the citizens to identify the frauds. So one part is using the Fraud Pro and Astra solution. The second part is citizens themselves report a certain cyber fraud calls what they get. So using these two platforms, we have been able to disconnect 35 million fraudulent connection in the network. And that is how you know that we had problems in, with these kind of cyber frauds were emanating from Jamtaras, Mewat and certain regions that were eliminated. Then there is another way they found, they went out and they started making calls from abroad with Indian numbers. So that is how another solution was developed by CDOT, that is called CIOR, which actually detects the spoof call. So today we were able to block 1.5 crore, so 15 million call per day using that. Now the calls have actually reduced. So they have found another way. So they are sourcing some SIMs from here going abroad so that they are legitimate SIMs. So for that another solution has been developed. So it is an ongoing game. So AI is really very, very useful because when you deal with the data, for example, data of our Indian consumer of more than 1 billion, it's very impossible to do it manually. So therefore, you need solutions which are AI based. We also have a Center of Excellence, and I think first of all, a lot of congratulations to the winners as well as the participants who took part in that. We have a Center of Innovation in CDOT, Entrepreneurship Cell. We also support startups. For example, we gave 10 awards to under program Nidhi to turn women startups in AI. Recently, we launched a Samarth program wherein we have awarded grant to the 18 entrepreneurs. Another 18 we will shortly take it forward. So initially, although we give less grant, maybe 10 lakh, but if the solution is good, we take them forward through our CCRP policy, CDOT Collaboration Research Policy, where the funding can be large. For example, 2 of the consortiums we have funded 75 crore each. So the money is not a problem. If the solution is good, I think we will be able to fund that. India is working with domestic and international bodies to ensure responsible AI adoption. While the potential is immense, so is our responsibility to develop and deploy AI ethically, inclusively, and with a human-centered approach. I'm sure last 3 days, a lot of deliberation would have happened on various technologies, various use cases, various solutions, and I'm sure that we will continue to collaborate, innovate, and lead with a purpose. Together we can harness AI to build a future that benefits everyone. So once again, my heartiest congratulations to the winners of Build a Thon, and those of you who could not make it this time, I'm sure that the learnings you would have gained will be of immense value and will drive you to success and in next edition of this Build-a-thon. And also, I think we will also go through as CDOT all the proposals what came in Build-a-thon, and we'll connect with you. And CDOT is always open to you if you want to use our facilities or infrastructure for anything. Please do approach us. We'll be very happy to collaborate with you. And once again, thanking TEC and the ITOT for giving me this opportunity. Thank you so much.
Thank you, sir, for your very informative and encouraging address. And now we have arrived at the most awaited segment of this Build-a-thon, that is prize distribution to the winners. It's a moment of pride to celebrate the innovation, dedication, and hard work of all the participants who have contributed in making this event a successful one. Over the past 2 days, we have witnessed young innovators presenting their ideas on the problem statements identified by this focus group, emphasizing on artificial intelligence native for telecommunication networks. This solution showcased a beautiful synergy between cutting-edge technology and their practical implementation. A heartfelt thanks to all the expert mentors who guided the participants and to our esteemed jury members for their critical evaluation and constructive feedback on the solutions submitted by the wonderful teams of this Buildathon. Now coming to the announcement of winners of this Buildathon, in addition to the first, second and third positions, we have special prizes for mentors and women's team to recognize their outstanding contribution. I now request Ms. Preksha, Research Scientist, IIT Bombay and Chair of Working Group 4 of FGINN, to kindly present the first special prize for mentorship. And the award goes to the mentor of team SSN. Ms. Gayatri and her team SSN are requested to come on stage. Let's give them a huge round of applause. Ms. Gayatri and team. Please come to the stage. Thank you, Ms. Preksha. Now, next I invite Sri Vishnu, Mentor ITU, to present the second special prize for mentorship. And this prize go to the mentor of Team OMAX. Team OMAX along with their mentor are requested to come to the stage. I think there is only one representative from Team OMAX. Please come. Thank you, Vishnuji. I now request Shri V.K. Roy, former DDG Telecommunication Engineering Center, to kindly come on the stage and present the special prize for the women's team. With great pleasure, I announce that this special prize goes to the team AIONET. Let's give this team a thunderous round of applause as they join us on the stage to receive this well-deserved recognition. Thank you, Roy sir. Now coming to the prize distribution to the winners of this build-a-thon for the first, second and third positions. I invite Shri Dipesh Srivastav, AVP Tejas Network, to present the award to the third prize winner. And the third prize goes to team No Wires Attached. A big round of applause for the team as they join us on the stage. Team No Wires Attached. Congratulations, team. Thank you, Dipesh. Now I request Shri Rajkumar Upadhyay sir to present the award to the second prize winner. And the second prize goes to team SNR. Please give team SNR a huge round of applause. Congratulations, team SNR. Thank you, sir. And now the moment of glory, the announcement for the first prize winner. I request Srimati Tripti Saxena, Senior DDG and Head DC, to present this award to the winners. And the first prize goes to, any guesses? Team Slice Mind. Let's fill this hall with applause for the champions of this focus group and build-a-thon. Okay. Congratulations to all the winners and to every single participant who made this event such a grand success. Remember, winning is not the only achievement. Your learning, commitment, and innovation throughout this journey are equally commendable. Now I request ma'am to present participation certificate to all the teams. Starting from team Cellucast, please come to the stage. Team Cellucast, no wires attached. Next, Omax. Yeah. After Omax, Sigvision, please be ready. Team members of Sigvision. Team Slice Minds. Team SNR. Next to Team SNR, Team SSN, be ready. Team SPV. Team AIONet. I also invite the last team, Tech Ranger, for their participation certificate. Team Tech Ranger. टेक रेंजर से कोई नहीं? हाँ अच्छा Now I request Senior DDG Ma'am to kindly present mementos to the esteemed jury members of the Thon for their critical evaluation and valuable feedback to the participants. I request all the jury members to join us on the stage, starting from Ms. Preksha. The next judge, Mr. Vishnu. I invite next Mr. Lee Myung-gyu. Yes, sir. Yes, Mr. Gyu Myung Lee. Doctor. And Mr. Ricardo. I request ma'am to present mementos as a token of felicitation to the supporters of this event. CEO C. Shri Rajkumar Upadhyay, sir. Sir. And to Shri Deepesh Srivastava, AVP Tejas Networks. Thank you so much, ma'am. As we move towards the conclusion of this memorable event, I now invite Shri Sujit Kumar, Director Mobile Technologies, Telecom Engineering Center, Department of Telecommunication, to deliver the vote of thanks.
Thank you, Jyoti. So finally, we have reached to the conclusion of this three-day event. So distinguished dignitaries, respected experts, international delegates, members of the focus group, Build-a-thon teams, and all the participants present offline as well as online. As we reach the conclusion of the third meeting of the ITUT focus group for AI native for telecommunication network and the associated Build-a-thon, it is my honor and privilege to deliver this vote of thanks on behalf of TEC, Department of Telecommunication. Over the past 3 days, we have had the privilege of hearing from leading minds, including insightful addresses by Sri Sanjeev Kumar Bidwai sir, Mr. Shijo Ono, Dr. Atsuko Okuda, Subendu Tiwari sir, Tripti Saxena madam, R.K. Upadhyay sir, and Mr. Deepesh Srivastava. I must also acknowledge the brilliant technical sessions from Professor Brijesh Lal, IIT Delhi, Professor Ganti, IIT Madras, Professor Manjesh, IIT Bombay, Professor Babi from Triple IT Delhi, Mr. Sabyasachi from Tejas, Mr. Kaushik Dey from Ericsson, Mr. Ajay Kumar from CDOT, and Avinash Agrawal sir, and Revati Madam from DOT, whose research and perspectives on AINN, 6G, AIML, and future networks added immense value to our understanding. Now, to all focus group members, your contributions through working group presentations and discussions have been central to the success of this meeting. A very special thanks goes to ITUT and Study Group 13 for laying the foundation of this focus group. TEC has been proud to be associated with this focus group, and it is heartening to see this initiative evolve into a dynamic platform for shaping AI native networks for the future. I would like to thank the focus group management, Chair Buse, the vice chairs as well as the co-chairs of the four working groups for giving India the opportunity to host this event. My gratitude also goes to our partners, Tejas Network and CDOT, for their role in supporting the Buildathon event. I would like to sincerely thank each and every Buildathon participant for your passion, creativity, and collaborative spirit. Your work showcased not just technical excellence, but also a vision for what the future of intelligent networks can look like. You are the living examples of what this focus group aims to nurture: innovation driven by openness, inclusion, and purpose. A sincere thanks to the organizing team at TEC, all the officers who have been given different responsibilities. Ms. Aarti from ITUT Regional Area Office, Mr. Thomas from ITUT, Mr. Vishnu, Dr. Preksha, present here, and FJNN Secretariat, who has been very supportive. I would also like to mention Professor Lee and Mr. Ricardo for traveling all the way to New Delhi and participating in the FJNN meetings and collaborating. I would also like to thank Rickson for keeping a demonstration of the AI native, which was viewed by all the participants present here. I would like to express my heartfelt gratitude to Secretary Telecom, Sri Neeraj Mittal sir, for motivating and encouraging us to work and collaborate with international partners in the domain of future and emerging technologies. My sincere thanks to senior officers from DOT, member T, member designate, advisor T, and others for taking out time from their busy schedules and attending this meeting in person. A special note of thanks to advisor T sir and senior DDG madam for trusting our team and giving us the freedom to perform and deliver. I would also like to thank my senior Sri Amit Kumar Srivastava sir and my colleagues from Mobile Technology Division TEC, Dhanesh, Jyoti, Drupad, for working day and night to make this event successful. Our research associates and interns, Susant, Mirza, and Kopal, have also put sincere efforts in organizing this event. Special thanks to my colleague, Ms. Ranjana, for performing important responsibilities in the meeting. I must extend my gratitude for support from Mr. Alex Vikas from International Relations Division for providing important support in visa clearance and all. I'm also thankful to admin, MM and finance divisions of TEC in arranging the logistics. Support from Vigyan Bhavan Management, MS Matro Art Studio and their event management team has been phenomenal. Lastly, to all the participants, whether from India or across borders, thank you for your engagement, your questions, your contributions, and your dedication to the cause of reimagining telecommunication network as AI native ecosystem has been great. We look forward to associating with you again in the upcoming FJNN meetings and in seeing the POCs and ideas from the Buildathon evolve into a real world impact. Thank you once again to each one of you for making this event as successful. Wishing you safe travels and fruitful collaborations ahead. Thank you all.
Thank you, Sujit sir. With that, we formally conclude the third meeting of FGINN and the Buildathon. Thank you once again to everyone for your active participation, enthusiasm, and dedication. We wish you all success in your future endeavor. Tea and snacks have been arranged outside the hall for all the participants. So thank you everyone and have a good day.